Everyone, if we could make our way into the Learning Point Education Room, then we're going to start our seminars in just a minute. If you can just make your way in, live stream will be coming up soon. Thank you. Hi, everyone. Thank you for coming to our third AbelCine EXPO. This is AbelCine EXPO camera-mounted recorders, in case you found yourself in the wrong room somehow or something. And to our live stream guests, I know there's a whole bunch of you watching today. I guess I'm here. Thanks for tuning in. And of course, this for you watching and everyone here, this is going to be archived. So we'll have this available on our website, so if you want to refer back to things and tell your friends. The AbelCine Expos really are about us trying to reach out to the community. We really want to connect with you and help impart knowledge. This is about getting past a lot of the confusion that's out there in the world. There can be giant conventions, there can be a lot of stuff on the internet, and there's a lot of piecemeal information. And this is about sort of clarifying for what people really want to know about and what we're really trying to get in a specific area. Like tonight is camera-mounted recorders, just to be able to get within that specific area, delve deeply into it, because frankly, that's how we like to sort of, we deal with something. We have an issue going on, we're trying to figure out how this stuff works, and we don't want to hear lots of general, we want to actually find out, well, what does this stuff mean, and what do I have to do in order to do the work that I need to be doing, either now or in the future. And so that's the idea behind AbelCine Expos. We really want to get your feedback as we go forward with this program. We're doing it in New York right now. We're going to be doing it soon in our Los Angeles office, and road showing it around the country as it makes sense to. I want to first thank a few companies that have been helping us out in making this happen. First off, both Zeiss and Neela have been wonderful in supporting the Learning Point in general. And Learning Point is just sort of our entire educational outreach system, if you will, our department of doing these seminars, of having classes, of having other events, doing our online work on our blog, just all the different ways that we try and reach out to the community to be able to work with people to help understand various types of technology that are out there. And both Zeiss and Nela have been extremely helpful. Zeiss, the great optics manufacturing firm, and Nela, the new technologies of LED lighting manufacturing, have been very proactive in sort of trying to help educate the community in what is going on. And it's all sort of a great give and take. You know, the manufacturers learn a lot by having you people come around and look at things, and you know, the feedback back and forth is really valuable to all of us. It's like, what are you interested in? What are your needs? And that helps learn what stuff to make. Tonight, this event itself is sponsored by AJA, Atomos, Convergent Design, and Sound Devices. Each of them will be presenting to you tonight of their wares, if you will, of their sort of solutions for the idea of camera-mounted recorders and the types of products they offer and why they went about making them that way, what they thought was going to be important to you and just in the community. And you know, they each have their own approach to it, and you know, there's never the perfect hat. It's the hat that fits you best. It's just which style works for you and which solution makes the most sense for what you need to be doing. So I'd like to thank all of those manufacturers for helping us out this evening to bring this event. And also want to thank both Canon and SanDisk. Canon is wants again to help people, you know, see the different things that are available and to understand really, you know, if you're going to have camera-mounted recorders, it doesn't mean anything if you don't have a camera to mount it to. Really, it does kind of, you know, it's having a car without a steering wheel or something. So Canon very generously help provide equipment tonight and also make provisions otherwise so that we could put on this event so that we have Canon cameras here, the 100, the C300, and the C500 all here so that we could see different camera-mounted recorders and the different ways in which they all function. So we thank them very much for that. And SanDisk is here. They are, of course, the media company that provides so many different solutions for just, you know, if you're going to have camera-mounted recorders, what are they recording onto? And some of the ones we have tonight actually use proprietary recording media that they have designed specifically for their units, but a number of them are using sort of general commercially available media. And SanDisk is a maker of very fine, generally commercially available media. And not only did they help out tonight in helping this event come forward, but in helping you to make your decisions and being able to make your purchases for what you need out of a camera-mounted recorder. SanDisk is working with AbelCine to have a sale on their products from now through Saturday. For various pieces of SanDisk media, we have a special sale going on for the next few days. You can talk to any of our AbelCine salespeople. Anyone tuning in can reach out to AbelCine, and we can help provide special discounted rates for the next few days on SanDisk media, a very generous offer from that company. So that said, I want to turn the evening over now to Andy Shipsides, who is our training director that runs the whole Learning Point department. Andy also does a lot of the classes here. And what we're going to be going, just to give you an idea of how the evening's going to go, Andy is going to present the idea of different sort of recording formats, if you will, different outputs from the cameras, what they can do internally, what they do when they send out a signal, and then what these different recorders can take in. And that might be that you'll start hearing things like 444 versus 442 and 8-bit and 10-bit and RAW and a codec and the bit rate and the bit depth. What are all these things? There's a lot of things to start kind of wrapping your heads around to get a sense of what it means for these different recorders and to use them. And so Andy's going to go into all of that after about an hour or so of that presentation. We'll, give or take, we'll see how it goes. And then our 4 sponsoring manufacturers are going to be presenting for a little bit on each of their wares and the idea of what we have, what they have to offer and like why they went about making their products in that fashion. And then during or after these things, we'll have Q&A time so that everyone can really make sure they get their questions answered and really understand what this stuff is all about. So that all said, I want to introduce Andy Shipsides.
All right. So I want to switch over. Ooh, that's loud. Okay. So as Mitch said, I just called this section formats and compression. So this this stuff. We talk about camera recorders and Lou, you've seen this presentation before. I know you have. Believe it or not.
Yeah, but the bar's not open, so I'm going to stay for it again.
Okay. There's a lot of terminology here that we talk about a lot. 444 recorders, 422, 10-bit, 8-bit, all these words that we hear all the time. And so when we go and talk about recorders and and outputs of cameras, we have to know what these terminology means to actually make sense of it. And so I just put together this presentation, which I hope isn't too long and boring and fun to listen to, or boring to listen to. I hope it's not fun to listen to. Wait, reverse that. I hope it is fun to listen to. I know there's a lot of smart people in this room. I recognize a lot of you. So, but for the crowd here and online, we'll just get through this stuff and ask questions as we go. All right. So, just the things that I would like to talk about. Resolutions, right? We know these 2 resolutions. I looked up the word resolution online, and I couldn't find. This is the first thing that came up. So there you go. I don't know. It's my joke of the evening. Not very. Didn't go up. Louis liked it. That was good. Didn't go over that well. Spend less time making keynote presentations. HD standard resolutions. We have 2 of them, right? These are 1280 by 720 and 1920 by 1080. We all should know these very well if you're in this HD world of ours. And I call these HD standards because they are the 2, right? There are many out there, but and beyond that, but these are the 2 we use today. So we'll talk about those 2 first. And here's an idea of a theoretical 1080p image, right? Which nowadays we started to call this full HD thing, right? For some reason or another, we thought, you know what? If we talk about 1920 by 1080, it might just be easier to call it full HD as compared to our slightly lower resolution 720p image. This is just an example, and you know this pretty well if you've been in this world for a while, that 720 obviously is lower resolution. And just for you out there that don't know what I mean by that, even 1080p is just referring to 1920 by 1080, and 720 is referring to 1280 by 720. I'm going to forgo the 1920 and 1280 from now on and just call it 1080 and 720. You know this stuff. We'll continue onward. So we know those 2, and I stole this gigantic 4K logo from Sony because there are things beyond that, and I'm just going to talk about 3 new standard resolutions beyond HD resolutions, and new standardized not necessarily in the sense that there aren't more than this, but these 3 are DCI or ITU spec, basically meaning the SMPTE and the ITU kind of agree on these 3 higher than HD resolutions. 2K at 2048 by 1080, 4K at 4096 by 2160. Note that both of these 2 resolutions are actually not 16 by 9. They're slightly wider than that. So they're not necessarily meant for broadcast application. The broadcast application format that you would see possibly in some future 4K world would be the quad full HD mode here, 3840 by 2160, right? Basically, they're just doubling 1080 both directions. If you need a graphic to go with that, hey, I got one, right? There we go. So 2K a little bit wider, and note that 2K is just a couple hundred pixels wider overall, and not even 100 pixels wider, just a little bit more. This 2K format adds something to you, but people often talk about 2K as if it's some major benefit over HD, and honestly, you're not getting a lot here. It's one of those things that, yes, it's nice to have when you need it for theatrical application, but it's more of a distribution format in that capacity than it is an acquisition format. But we have 1080, we have 2K. If we keep going beyond that, and we think about 4K, if we take a 2K signal and we multiply up and down both directions, we get that 4K 4096 by 2160 format. Put that together, voila, there's our 4K. So that's what that 4K is. It is just literally a combination of those signals together. If you take a camera like the C500 out there, you put it through the KeyPro Quad, it'll actually put out 4K over 4 SDIs. We're actually composed of those 4 individual images. You plug into a 4K monitor, quadrant 1, quadrant 2, quadrant 3, quadrant 4, they turn on individually. Essentially, that's 4K composed of 4 individual 2K signals. Now, again, the broadcast world, we probably won't use this. You would use the Quad HD standard, 3840 by 2160. Again, not losing that much. It just kind of bums people that they can't get the actual 4K number in there, I think, right? They want to see that 4096 because it looks good, and they go, oh yeah, I have 4K because I have that 4,000 pixels across. But that's not necessarily a very important thing, I suppose. But if your application demands it, you have this. So cameras like the new Canon cameras, new Sony cameras can actually record in either of these modes or output either of these modes. Or if you're shooting something like the Red or an F65, you can certainly generate either of these things from the raw material recorded. So they're there, and we'll talk about with the recorders today, some recorders that can take raw material out of a Canon camera, for instance, and generate either of these resolutions. Yes?
So all the 4K consumer TVs that they showed at CES this year all stayed with the 16 by 9 form factor, and they're going to go to the quad thing. That's kind of been decided, or were they showing them in a 4K aspect?
Actually, the majority, and the question is for the audience, if the audience didn't hear, were the majority of the CES displays, the new 4K displays shown at CES, were they 3840 or 4096, right? So the majority were 3840. Obviously, for manufacturing purposes, just combining multiple panels together in the same aspect ratio is easier to do. There are some obvious 4K monitors in our world. The new Sony X300 or whatever, their 4K new monitor is 4096 across, but that's a rare bird. So I think we'll see the majority of consumer sets being that 3840. And it is fairly well standardized at this point already, just because that's who runs this world, the consumers, right? They're going to buy the TVs, so we'll produce content for them. And we'll have to letterbox our 4096 in there if we want to keep the whole resolution, right? So just to be aware, that's something out there. So those are our resolutions, right? We got lots of them. But there's actually way more than that in the sort of non-standardized world. But those are the ones we care about because we're probably all going to be, in one way or another, already producing that 1080p content, or we may be producing this 4K content in the future in either of those formats. In the US, though, we have some standardized frame rates. And the reason I want to bring this stuff up is because there is a lot of modes in these recorders today that we're going to talk about, and having the knowledge of what they can and cannot do or the issues therein is important. So in 720, for the most part, it's a 59.94, 59.595. That's a wrong number there, but anyway, it's a 60p recording in 720 for the most part, right? So that's just that 720, even though there are standardizations for 24 and 30. For the most part, a camera is going to output that 59.95 recording output and not a 24 or 30. Now, it's possible to do that in 720, but it's unlikely. However, in 1080, you may be doing things like 2398p or PSF, we'll talk about that, and 24p or PSF, we'll talk about that, or 30p or 2997p. And you notice already we're talking about this 5994, 2997 thing, so I'll explain a little bit of why this is important to the recorders as well, because it's important to know what your camera is outputting, because some of these recorders actually have the ability to change your frame rate in the recorder itself, so you could actually unknowingly record the wrong mode in the camera or in the recorder. So really quick first, just for anybody who's not aware of the big difference here, I've actually surprised in the world today how many people coming from into the business in a sort of new world of progressive cameras. They never heard of this interlaced thing. They don't even know what it is or how they got there, So just as a concept really quickly, progressive versus interlaced. We have this thing called progressive, meaning that in a progressive image, every line or every part of an image is recorded at once, right? So think of it as progressive frames as being essentially a stack of individual still frames in a recording. Where in interlace, we're actually talking about alternate lines of recording or fields, odd and even, right? So in 1080, for instance, we have both interlaced options as well as progressive. So It's important to note the difference between the two and how that plays in. And we've seen interlaced artifacts like something like this here. We actually see the sort of splitting of fields as we move, because progressive images will actually capture individual full frames, where interlace can actually split up in some situations when panning quickly, like we see here, because we're actually capturing odd and even parts of the image as we go. So 720 is strictly a progressive format, where 1080 can be interlaced or progressive. This does play a big part in our recording options, as we'll talk through this. I guess my font's got a little funky here, so I apologize for that, as I change between computers, I suppose. So why 5994 and not 60i, right? So just a good point to the, we saw all those frame rates a minute ago. We saw all the different variations in the NTSC world or the US world. Well, back in the 50s, there was this whole thing called color introduced, right? We talk about this a lot in our classes that we do here, because it kind of messed us up big time. Back in the 50s, we introduced a color signal into the pattern, into television sets, and the majority of television sets at that time were black and white. They introduced the color subcarrier over the black and white signal in order to allow color TVs and black and white TVs to sort of coexist. And that caused an issue with audio, and so they had to slow down the video ever so slightly, right, to fix that problem of the audio being interfered by that color subcarrier, right? So they slowed down the video ever so slightly to 59.94, and ever since then we've been really just screwed over by this weird-ass format, right? And so that's the world we live in today, in this sort of odd, slightly slowed down video space. And it's never going to change. People ask, why don't we just go back to progressive now that we're digital? We're not worried about that in the broadcast world. Well, we're set. That's just the way it is. It's legacy. We're always going to be this slightly slowed down format in the world of television production. And really, that sort of seeped into cinema because it's easier just to acquire at this slightly slowed down rate if you plan to ever deliver on television or other mediums. So this rate actually sort of perpetuates itself downward through the other frame rates into things like 24 being 2398 and 30 being 2997. This is all perpetual together. But it's a big point because some cameras can actually do 2400, actual 24, and some cameras can do 2398, depending on the camera mode. And so we have to distinguish those two things and know that, when it is to choose one or the other. And usually you just choose 2398 and you didn't even know you did it because the camera only really does that even though it says it's 24. Blah, blah, blah. We'll keep moving forward. 60p is a US standard, but really it's 59.94. That's what we broadcast. But in 1080, we don't broadcast in progressive. We broadcast in interlaced in 1080. But that, just as an idea of what that is, would just be 59.94 progressive images a second, full images being displayed to you. It's actually rare to see this in 1080 as broadcast. You don't, because we can't handle that bandwidth. However, you can now capture with a lot of cameras in this progressive mode, right? So that's one format, but we generally are going to start to see things in 60 as not interlaced, as not progressive, but interlaced, right? So here's an idea of actually capturing in an interlaced format. And by the way, the really confusing thing about this sort of format, and it happens all the time for a lot of people, is that 60i, as we call it, which is a US standard for broadcast, really means 59.94i, interlaced, right? But also sometimes, like companies like AJ, for instance, will actually call that 29.97i. And why do they do that? Why do you think they do that? Just as a wild guess, throw it out to me. Anybody? Yes?
Because it's European standards. In Europe, I think they consider our 59.94i and their 29.97i. Because it's a full frame. Because they think of the frames per second and everything for the fields per second.
Well, if you think of it, I mean, I think someone a couple shouted out there too, Dan, but the idea that two fields equal a frame per se. You put the two together and it equals a frame, so it's sort of a halving of it's the idea. So it's just it's a nomenclature thing. It's an idea. It's what's happening here is more about the fact that, if you put two fields back together again, they equal one frame. The problem is if you're thinking of actually acquiring in this 59.94, as you shoot here, you can see the even and odd. Basically, we're only capturing even and odd fields. This is my old Muybridge sort of still sequence here. And when we put these fields back together again, if motion has happened, we can't have a tearing effect in the video itself. Things have shifted between the field captures. So we're actually acquiring in this format is not necessarily the best for the look of cinema. But for but in fact, most news organizations still acquire in this sort of frame rate, even though that's the case. But the more important thing about this format is it is a broadcast standard, so we often have to conform back to that. So there's that, right? And then progressive frame rates that we've seen here before, 2398, 24, 2997. I have a lot of typos in this one. They're all just standard progressive images per second, right? Just images in a second. Nothing to worry about there. But it's not often the case that we can, it's often the case with a camera that even though it can acquire in this progressive mode, it may not output that progressive format. What happens along the way sometimes is the cameras, for whatever reason, legacy for many parts of it, they actually output something slightly different, like progressive segmented frame, right? We saw that before in the sort of frame rates thing, that a lot of cameras actually output this thing called PSF, right? Progressive segmented frame. So what it does is it takes a progressive image and splits it into two fields. And that's really just another word of interlacing, basically. It is interlacing that. The difference being that between a 60i signal that we saw a moment ago and PSF is that the fields originate from the same original frame, right? So we're actually taking one original frame and splitting it into two fields, mostly for purposes of tape-based systems at the time when they created this and CRT displays. But in reality, these formats only exist between two systems, right? Or for the purpose of display. You don't necessarily ever get PSF on a computer for editing it. You don't see it that way. In fact, we just see it in between two systems or on a tape stock, for instance. Sony really pioneered this sort of idea of splitting frames into fields for purposes of recorders, etc. So 2398p could also be equally represented as PSF just by splitting it in half, which we might actually call 48i. Well, it would actually be 47 point something 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 I, right? And the reason why that we sometimes see it like that is because it really is PSF really is an interlaced idea. It's just that no one likes that word, you know. So we use the PSF thing, and it is different because PSF means that it's acquiring those two fields from the same original frame. I have another example of this. But 48i, if you actually plug a PSF signal to a Sony monitor, it'll tell you, oh, I got 48i. It's a little strange, right? But that's why it's coming from. 2997p is 30p, right? Another word for 30p. And then when you split that in half, it becomes something like 60i. In fact, it is 60 interlaced. So it's easy for a news organization, for instance, to require in 30p and show things back in 60i without any complicated conversions. Yes? There is true 30p.
People say that.
Yes.
You have to make sure because that's a huge
problem. So what Louis' point was just there was that there are true 24 and true 30p. They do exist. They're just not really right for our world, especially in this format, which is mostly a broadcast format anyway. You're never acquiring that. In fact, most cameras that say they're shooting 30p actually are not shooting 30p. They're shooting 29.97. It's a big distinction and importance along the way with this sort of stuff. But for recorders, you'll notice that a lot of cameras have this output, PSF. And the reason they do that is because they want their recorder to be able to recombine those fields back together for you to record a progressive feed. And it is a little bit of a legacy thing here. There are some cameras that can put out truly progressive feeds, right? They don't need the PSF thing. But it depends on the recorder and the camera. So like the Red camera always puts out progressive, right? And so when the Red camera came out, at first with some recorders, you couldn't record it because the recorder could only record PSF. So these are why these things matter that matter so much, right? They cause compatibility issues. But just to see as an idea, PSF, what it would look like if I took these three original frames. Basically, I'm splitting one original frame into two pieces, interlaced pieces. You can see I'm just sort of splitting evenly. And this would be the same in 2997 or 2398. It's what we call a 2-2 pull down, right? It's just splitting every frame individually in half. And then, but again, in terms of how you see it or acquire it, it's basically then becomes progressive on the other side of this process. But probably the more common thing that we see, and what's important to this lecture as well, is this 2-3 pull down sort of idea, which is the conversion of 2398 progressive into 59.94 interlaced for broadcast. Basically, this is how we're going to see most of our 24p material on TV. It's been pulled down. It's been converted. This is a very old idea in the sense that we've been doing this since video really came along, originating in film in that case. and this is the same process that we see every day in a lot of cameras. In fact, out here on the showroom floor, we have recorders that are hooked up to cameras that only output 59.94 interlaced, right? So even though they're acquiring at 23.98, right? So like the C100 out there, the C300, a lot of Sony cameras, a lot of them are stuck with only outputting this 60i, even though they originate from this process. So a lot of these recorders that we're going to talk about will have the ability to remove this pull down removal process live. Basically, I plug the signal in the case of like the Ninja out there, it actually tells you to wave your hand in front of it when you plug in your 60i signal, where it determines the first field, the first pull down cycle of the 2-3 pull down sequence, and it'll remove that frame rate, that pull down from it, and get you back to 23.98. Again, important for recorders. Do they do this, right? That's a big option to have if you need it, if you know your camera is outputting this. So many less expensive cameras will be only outputting 59.94, and you have to apply that 2-3 pull down to make it work. So that's just an important thing. Now, if you're in European or anywhere else in the world that's sort of a PAL standard 50 hertz system, your world is much easier, right? You're just 50p, your 25p, your 50i, your 50p. Basically, it's much easier to be, to live there in that sort of capacity, because you only have these standardized formats, and you don't really have to worry about all these weird conversions, right? If it says 25p, it is 25p, not some 24 point blah, blah, blah. So this is very easy sort of change there. The good news is all these formats we've been talking about and frame rates, at least all these frame rates in standard 1080 are supported by the majority of these recorders. But you have to know what you're getting. It's very, very common for people to get on the Key Pro Mini, for instance, they'll plug in a 60i signal, 59.94, into that recorder, and it'll say 2997i, right? And they're very confused as to what that means, right? So it doesn't, and so you have to be able to identify what's going into that camera, even when you don't. When it gives you a cryptic message like that. So that's why we go over this sort of stuff. Now, so that's frame rates, that's resolutions. Just a little bit more on this thing called subsampling and color compression. I want to go down this road here with you guys because what's the whole advantage, the whole reason behind going these recorders versus just recording internally in the camera? A lot of the camera internal recordings, while they're very good quality and we all know that they can give us results, they tend to reduce the amount of information on your original video signal in order to get longer record times, right? That's the whole purpose of a lot of internal recordings. So when we go down the road of an external recorder, we may get the benefits of less compression, right? I want to talk about compression not in the sense of long GOPS and MPEGs. I want to talk about sort of base compression that happens in a lot of cameras to reduce data, right? So first we're going to talk about something, just a terminology thing about this thing called RGB, right? Everyone heard here about like an RGB camera, right? A camera that can output RGB, right? We've heard that in a couple there's lots of head shaking. That's good. So like a camera like the C500 out there, or an F3, or much higher end cameras that can put out an RGB signal, meaning that in an RGB signal we essentially are producing 3 solid images from that sensor: a red image, a blue image, and a green image, all with its own luminance essentially associated with that image. Total color separation that way. Now this is a great thing, but we do have some redundancy in that system, right? So, which is the luminance component. And because of that redundancy and the fact that it uses more bandwidth, and also if you think back to that whole old example that I gave about color subcarriers over black and white, we've actually generally don't use RGB as a means to broadcast systems or to output signals. We actually use this thing called YCBCR, which is a digital, in the case of YCBCR, or YPBPR, which is an analog idea, where we've essentially taken the image and pulled out the black and white luminance or luma information and separated the color channels into a blue difference and red difference signal, right? Right away, by doing this, we essentially have thrown away a lot of redundant luminance information. We've effectively cut the bandwidth in half. But this is sort of the first level of compression that happens in a camera in the sort of simplest terms, because all cameras are going to start off in some sort of RGB setting at some point in their processing of the image. So this is something that might happen in the camera. If a camera offers the ability to give you the RGB signal, go for it if you can handle the amount of data that's coming out, right? So right away, RGB versus YCBCR, we have to know what the difference is and why we might choose RGB, again, for full color separation if we have that option, right? We don't always have that option. Some cameras just don't output that. But in a YCBCR signal, each pixel contains 1 lumina value and 2 chroma values. In RGB, each pixel contains essentially the equivalent of 3 extra luminance values and 3 chroma values. That's more of an analogy than a truth, but the point here is that we're basically cutting that information in half by reducing by separating the color and reducing sort of redundant information, even though it's very useful to us in some post situations. So YCBCR is the most common format that you're going to see out of a camera, right? We're not going to often get RGB out of a camera unless that camera gives you that mode. And it is going to insist that you have higher data rates along with that. So along with that, though, with this whole idea of YCBCR, comes the addition of something called color subsampling. And I'm getting to the end here, guys, so just hold with me. I think we can get there. So color subsampling is a reduction of color resolution. Reducing color also reduces data rate. It is not necessarily easily visible to our eyes. We don't necessarily perceive the loss of color resolution that much, right? So we can reduce the amount of color in the image, not actual colors that are there, but the sort of volume or color resolution without necessarily affecting the overall vision of the picture. And we call this subsampling, or the terminology is often this sort of 444, 422 thing, right? It's a reduction in color information. So I'm just going to give you, I'm not going to give you the boxes with the little Y's and the C's and all the little things in there. I'm just going to give you a really curse visual example of what's sort of happening. It is just an example. But in a 444 color system, we essentially are not reducing color versus luminance, right? We're just keeping luminance and color at full resolution to each other. So imagine if you were to separate, and this is again just an example, luminance, black and white information from the color difference channels, right, in an image, then, and I didn't reduce the resolution of these, we call this 444. Basically, it's referring to the fact that it's not reducing color or luminance, right, in that idea. It's just a concept thing. It's more of an analogy than anything. How it actually works is very different, but there's the 444 idea. This is not often done in YCBCR because there's no advantage, right? Why would I do this? Why would I choose 444 in this mode if I could actually go further and reduce this information even more? So generally speaking, I would reduce the color information, and I just get a curse visual example here, by essentially reducing the amount of color resolution in half into something called 422. Now it's going to happen on both of my color channels, and here's an idea of what it might look like. And in fact, if you look at some old tape formats, it actually was stored this way on the tape as black and white and then color reduced difference maps, right? Basically, this is an idea of 422. So we've thrown away a lot of color information in doing this, right? So, but 422 is very good still. It's definitely something we're after. Yeah.
What classic situations would compel us to do something like this?
What's that?
Why would we have to do this?
Well, it's really just about compression or reducing data. The reason that this is done is to make the signal smaller. Again, just data rate reduction, yeah, for digital signals anyway. I mean, in an analog world, it could happen too, again, for the same reason of just fitting more signal in that pattern, on that pipeline. So, it is all about data reduction. If you go further than that to something like 411, you've even more compressed your color down. Now, 411 is more of a legacy format at this point. We don't see that a lot because it does so much horizontal color reduction, right? So it's just, again, this is just essentially just squishing my color image down. You can kind of see it squished in there. And then when I see it back in the real world, it's sort of stretched back out over it, if you think of it that way. This is just an analogy, right? So that's another idea. But we don't really necessarily use this that much anymore. We do something instead called 420, which essentially which averages and shrinks in sort of both vertically and horizontally, right? So it's sort of like shrinking your image instead of just doing it all horizontally. It's doing it both vertically and horizontally to get a reduction that's a little more even. And so when we expand that back out again, we get a better response. And so 420 is the most common color subsample you'll see today in most little cameras. In fact, a lot of times the reason why you go with an external recorder is to avoid this format, right? Because you can see that color is being reduced a lot. I'm not saying that it's not useful, but there is that kind of thing happening along the way. So a lot of cameras will, while they'll record 420, they'll output 422, right? And 422 has advantages. It's just basically a lot more color data, which is very important for us, especially in visual effects, etc. So a little bit on bit depth, and that's basically that bit number you see, the 10-bit, the 8-bit thing, defines, what I would say defines the amount of color variation available per color channel per pixel. 8 and 10 are the most common ones you'll see in little cameras, but as you go higher up into RAW cameras, you hit 12, 14, 16-bit, right? And just you can think of it just as a number. If you want to play the number game here with it, and the reason why, and by the way, people this is a confusing analogy sometimes where people think the number 8, what the number 8 means, so stops or something different. I want to dispel that because this is 8-bit color refers to 2 to the 8th channel, 2 to the 8th, which is 256, right? And that's basically saying that I have 256 variations or shades of gray per color channel in a given system, right? A given video signal. And if I multiply that through, or if I either do 256 to the third, or I triple my 8-bit, that becomes like 24-bit color, or it basically equivalates to 16 million color options in the 8-bit world, right? If you're an old computer guy like me, big dork, you used to pick up old VGA computer cards, and it would be like, oh, here's the 16 million color mode. You turn it on, turn it off, right? And you could be in different modes and see the effect on the image, which is basically saying I'm 8-bit. If you're a Photoshop guy, you see the same stuff all the time. They refer to 8-bit as 24-bit. Same thing. They're just combining the RGB channels together. So in that space, you see we have that many shades of gray per channel, right? You go to 10-bit. Now we've gone 2 to the 10th, 1,024 shades per channel. You can think there's 30 bits in the Photoshop world, or about 1 billion colors. So 2 bits, a lot of difference, right? That's the big thing here. We go from 8 to 10, we have a big increase. So again, with external recorders, most of them are recording in 10-bit formats, right? So our camera may be 8-bit, but it may be 8-bit internal, but it may be outputting 10-bit. So I can get a big advantage there in my recording by going to this, basically going from a 16 million color world to a 1 billion color world, you know? So there's an advantage of these external recorders, and the reason why they'll keep talking about 10-bit formats is because of this big difference here, right? That's an important thing. And usually in this world with the little mini recorders, you know, unfortunately, the cameras sometimes basically just only output 8-bit, so you're not really getting an advantage. Just know that you can sometimes when the cameras vary that way. And if you go to 12-bit, just to go up to the next logical extreme, to the 12, 40, 96, 3 channels, 68 billion colors, right? You go to 16-bit, you're talking over 600 billion colors. So I mean, it just keeps going and going and going in terms of increase. There's a lot more information in this sort of 12-bit, 10-bit world than there is in the lower ones. But I'm not complaining. Obviously, there's some great 8-bit formats out there. We know they exist. We use them all the time. The cameras, they do work. So now we've talked about all these terminologies, right? Now we throw all these things together. So if you see something like, you know, ProRes 4444, by the last 4 refers to an alpha channel. You can pretty much ignore that for our application on set. There are people that will do this in post, but the last 4 is just referring to that in ProRes 4x4. So looking at these things together now, we have Apple ProRes actually supports a number of resolutions. We have a Key Pro Quad here, which records ProRes in 4K, right? So it's not limited to 1080 there, but as an example, there it is. You can do 10 or 12-bit. It is a 12-bit format by standard in Apple ProRes. It can do 444, obviously, where its name implies, RGB, and it can do up to at about 380 megabits per second. So it's a big format. It's a pretty hefty data rate there. But again, now we see all these terms together, and it looks pretty good. ProRes 422HQ, 10-bit 422, YCBCR, doesn't do RGB. Because RGB doesn't do the 422 thing, it just does 444, right? At 220. I have a DNX 220, 1080, 10-bit 422, YCBCR at 220 megabits. These are the most popular recording formats today for the most part, honestly, in external recorders. And most of the recorders out there, yes, I think all of the recorders out there do at least these 2, right? 422, ProRes, or one or the other. I mean, or beyond that in terms of quality, right? So they can do this or better, right? So this is, you know, compare this to a internal compression, which may be 8-bit 420. It's a big benefit when you go to these sort of things, right? So beyond that, we have cameras that record uncompressed signals or raw signals, right? Which would be no compression. These are compression formats beyond that, right? So you look at something like the Gemini out there, which is an uncompressed recorder, it's going to take basically the uncompressed signal coming out of your camera, well, knowing that the camera already did some kind of compression itself before it got there. It may have gone from RGB to YCBCR, and it's going to take that signal and record it to you in an uncompressed format. So it means it's not going to add any more compression, right? And just to put that in context, basically it takes whatever the SDI is giving it and records it, right? So just as an idea here too, in reference to the recorders, there's a single link HDSDI signal, right? If you just take a signal out of a camera right now, it has about 1.5 gigabit per second data rate. That's the actual data rate maximum at 60i, the full sort of frame rate of that. It is, I'll put these all on the frame here. It is a 422 10-bit signal, right? That's the standardization for that. It can support up to 2K with the special spec, but we don't generally see it there. And it does either up to 30 frames per second in 1080 or 60i in 1080, right? So that's all you can do on a single link. Again, in 1080, 720, it can do 60 progressive, right? So we take that signal, great, awesome. And it would say we double it, right? What if we want to get more out of the camera, right? So we could double that together. We could put two cables together. We call that dual link, right? 2 times 1.5 gigabits per second. What does that equal? 3, all right. 3, and we call that, which is 3 gigabits per second, aka 3G, right? So there's a lot of cameras now that have 3G spigots on them, right? Basically just 2 cables in one. And that signal, you can do 444 10-bit signal in HD. You can actually do on some of these now, you can do up to 12-bit. I think the Pix 240 out there, and I think the KeyPro Quad, you can also do 12-bit. Up to the KeyPro Quad can do 2K 12-bit. The Pix 240 can do HD up to 12-bit in 444 in there. So we're really pushing out the signal into that device to get even more information into it. You can do up to 30p in 444 or 60i, or in 422 you can do 60p. Imagine as you double either the frame rate or the color space, you're doubling your signal, the amount of signal you need. So you could do 30p, up to 30p in 422 on one cable. You put 2 together, you can do up to 60p, right? Or you can do 30p in 422 on one cable. Put 2 together, you can do 30p up to 444, right? So it's just a doubling of bandwidth that we're doing here to get more. Now, of course, we can push that even further if we really want to, and some cameras are. Dual 3G SDI, like Alexa does this, a C500 can do this, and other cameras in the future for sure. They can do up to 444 up to 60p, right? Basically, they've taken that same bandwidth limit, that same bandwidth of a single 3G, put 2 together. Now they can do 30p, 444 on both signals, getting up to 60p, 10 or 12-bit, and up to 120p in 422. In fact, this is implemented on the Canon cameras. They can actually do that sort of thing. And we'll see that. This is a rare thing. This is kind of a new idea. But they're using dual 3G to pass through that signal at that rate. And I think you can get that on the Quad and other devices in the future. So it's an interesting idea. And the reason we bring Canon cameras, we like them obviously, but also they can do all these weird things, which is really interesting to me, that they can do these formats that are sort of out there and brand new. So these are the sort of potentials here. But again, the bandwidth as you go up here is really increasing. You know, we're talking gigabits and gigabits per second of uncompressed data. So finally, and this really cursory raw data, and just because people often confuse it about, you know, what is raw data, it's basically unprocessed sensor data. It may be compressed or uncompressed, but it is unprocessed sensor data. So when we have a raw recorder, like I think the Convergent out there is the one we have, it isn't it's not video being sent to it. They're just using the SDI spigots on the camera to send data over. So either both the Alexa and the Canon C500 use SDI cables to send raw data, but it is just data. Video must be created from that data. Now, when you look at the Convergent Design over there, you see a video on the screen. Look, that's video, right? Well, the Gemini is actually generating that video for you live from the raw data. It's debarring it, demosaicing it, giving you that image back to look at the screen. But that's not actually what's being recorded. You know, this is an idea, goofy idea of what raw data would look like. This is if you literally just plugged the SDIs from the Alexa into a monitor, and this is what you saw. Basically, they're using that signal to send that raw data, and my monitor doesn't know what to do with it. It just gives me this gobbledygook. So it's not really, it's the matrix, yeah, exactly. So this is very raw data, sure. So the Gemini, if you just plugged it in when it was in the regular non-raw mode, you might see this. it would go, whoa, watch out, you're giving me something I don't know. But you could process that data and get something out of it. But that raw data could be in 12-bit, 14-bit, depending on the mode. ARRI raw is 12, Canon raw is 10, but they're uncompressed raw data signals, and they have big data rates to go along with them. So that's my really fast-talking presentation. I hope I didn't lose too many people on it. But the key things to get out of it here, right, is that the things we're looking for generally when we go with an external recorder is resolution-wise, which ones does it support, right? Does it do generally you want it to do 1080, and they all do. Do you want to go raw and go higher res? Then you have to consider that as well. That's a bigger consideration. Frame rate-wise, it's probably going to support most of your frame rates. It's the higher ones that could be a little out there. You have to see what they support frame rate-wise. And if you're using a cheaper camera, like say you get the 5D3 that's coming out with a new update to give you clean HDMI output, that's going to be 60i. But even though the camera can shoot 24p, so you might want a recorder that can remove that pull down, right? So that's another thing to consider. Pull down removal is a nice thing, or you do it in post. It works either way. So that's a consideration as well. And all those frame rates there. What kind of format are you going to? You probably want to go to a 10-bit format if possible, and you might want something in 422. And all these recorders are going to give you at least that, if not 444 or better. So these are all improvements over those original internal compressions options. That's why we have these external recorders, to get more color, more bits, and all that stuff. And why do we care? Well, we're all in the room because we are big dorks and we think that it's important. So that's what it comes down to, right? Is upping your camera quality versus what's in there. And sometimes we just have to do that because our productions demand it. They need the quality. They need to use this stuff for visual effects work, etc. So that's why we're here. Hopefully, in this sort of truncated little section here, you got some words and some terminologies there. So if when these recorder companies come up in a minute, you can go, well, does it do 3G 444? Or does it do, how does it get 444 in, What frame rates does it support? If you got all those sort of things together, then this is a good thing. So that's it for me. We'll move on, right? Yeah. Okay, good. Thank you.
Thank you, Andy. I think the one other thing I want to just touch on real quick before the different manufacturers come up is the idea of what are you posting on? Because these different formats, these different recorders will all come up with different, we'll each be able to record in different systems. There are things like ProRes and DNX HD, and there's Cinema DNG, and there's Canon RAW, and there's ARRI RAW, and there's these different file structures that, and you can have this one that is a certain data rate and it's a 422, and then you can have this other one that is also that same data rate and it's 422. But one is native to one edit system and one is native to another edit system, and depending on who your client is, that's the one you probably want to be shooting in, regardless of image quality, pretty much the same thing. So you can, it's not just sort of like, I'm up high on the mountainside and all I care about is absolute image quality. We're here to work. We're here to get stuff done. And what can matter with these recorders is that, you might have a camera that does a perfectly good job internally in it, frankly, anyway. But if it's, if you really need a cheeseburger, then you could have something that makes the best hot dogs in the world. You still got to deliver a cheeseburger. Really comes down to that. So some of these recorders just help you get through the job, get your work done, because I've got to shoot on this day and get a deliverable to this client so that they can get out for their job they've got to edit it and get it to on air or to their client, in a 2-day turnaround and whatever it might be. And just saving that step of taking this stuff, which might be in this camera's format, and then for what it would mean to get through their edit system, because this is what they've got, this is the stuff they work on, and then out to post. You could really, that's the difference about getting the job done or not getting the job, or you getting hired to do the job or not getting hired to do the job. So some of these recorders will record in a format called ProRes. That is the native codec for Apple, for Final Cut. Some of these recorders will record in DNx HD. That is native to Avid systems. Some of them do both, and you can switch back and forth depending on what you're doing. Some of them will also record in DPX file structure. Some of them will have the ability to take RAW and just give you a RAW file, capture that, and then you can, through various post programs, turn it into whatever you need to turn it into. Some of them take a RAW signal and turn it into one of these other post-edit systems codecs so that you can just, all right, I'm going to work in that. And it's, you know, there's pluses and minuses to all of these things. It's just giving you those options. So that's some of what the manufacturers are going to talk about, and I think it's, you know, what's important used to be that you had the camera over here and you had the post over there, and they never talked about each other other than to, you know, throw spitballs and say terrible things about, you know, oh, they screwed up my stuff, or I had to rescue his stuff. You know, it's always, they always say that as stuff anyway. It's, you know, it's all little fiefdoms, and, you know, whoever has the client's ear at that moment is the hero, and the other guy's, but that's just the world we live in. But the world we live in reality every day is that these two sides are coming inexorably together. And before you shoot a frame, you need to know what you're doing later on, because that's going to guide you in what you should be doing. And you don't want to be, well, I'm beyond that. No, no, no. They're going to have to pick up the pieces of what, you know, they'll have to make it work. That's who's going to get the job, who's going to get the job done, and also who's going to do a better job of it. Because if you understand, oh, I'm actually outputting, the finished version is going to be done with this, it might be foolish of you to shoot in a given format. You know, that's never going to, if someone's doing a webcast of something, then delivering them 4K RAW is just going to be like going to blow their mind, and they're never going to get their job done. And other times, if they're going out to a cinema delivery, and for your convenience sake, you wanted to shoot in this highly compressed format on this little recorder thing because you can just get out there, and then it's going to look terrible on the other end. So you have to really consider what are the steps in between. It might be going through various stages of post and then bounced up to a satellite, going down to a cable provider who then divides it up even more. And by the time it makes it to air, it's been so compressed in so many different ways that you can barely see it anymore. So you need to start with that much more information because it's going to get chewed up along the way. These are all considerations. If it's something that I'm shooting it right here and this guy's going to take the material and going to go through post and he's just going to present it to his client, and it's just, you know, they're going to be distributing DVDs to their clients or doing a Blu-ray release or something like that, and there's 1, 2, 3 steps, and that's it. Wow, hardly anything's happening to it, and I don't have to worry about too much going on throughout these steps. These are all considerations to your job and getting your work done, helping you make the decision about which of these devices. There's no one machine that's the one. Otherwise, we'd say, you know, sorry, guys, we're only going to present one recorder today. This is all you need to know. There's not. There's different tools for different jobs, different uses for the work that we all do. All that said, I'm going to now let the manufacturers present their wares and what sort of solutions they have available. So I think we're going to start off, where do I hit play? I hit play. And it plays. AJA is the first company. Tony, come on up. Do we have the hand mic? Ah, he's all set. Look at that. Look at that. You have the floor, sir.
Thank you, sir. Hi, everybody. How are we doing? Good. Thanks for coming out. Thanks to you guys for giving us a little bit of an opportunity to kind of chat with you. And as you said, show you some of the solutions that we've got for how to handle this interesting and kind of convoluted world of 4K that we're finding ourselves rushing headlong into. So just real quick, introduction type stuff. I'm Tony Cacciarelli. I'm the product marketing manager for AJA. And, excuse me, I just wanted to real quick, we're going to talk about the KeyPro Quad. This is our new recorder that we're coming out with that is not just a 4K recorder, but it will also do HD and 2K and some of the other formats that Andy was talking about earlier. And I really like what you were saying, Mitch, about thinking ahead. I've been banging that into people for years. Ever since we made the switch to HD, it was one of those things, it's like, you have to plan ahead, please. So it's good advice. Heed that, and you will actually have an easier time of it, I think. Quick history lesson before I move on too much further. How many folks are familiar with our Key Pro family of products at AJA? Okay, great. Excellent. I'll make this brief, but we did kind of start off with our Key Pro. This was the first device we released back in 2009, and it was really the first device that allowed you to take a video signal in, record it as a ProRes file onto a removable drive that you could then take out, bring to your edit system, load up, and be able to edit with it. So it was really about compressing that interval between shooting something and being able to work with it. And Key Pro was really popular for that. It became widely used as that kind of a device, and now it's kind of evolved into even a playback device, which is a whole separate story. But that concept of bringing the camera and the edit closer together is really kind of where the Key Pro line lives. And we took that the next step further with Key Pro Mini, which was a much smaller unit, easier to mount on some of the smaller sized cameras that we saw coming out. HD capable, it could do standard def and high def, really lightweight, really rugged, designed for use in the field. And then the Key Pro Rack was the next step on that, that bit that I was talking about with the playback, where now we've got a device that's really starting to become more of a VTR alternative, something that people are using as a replacement for tape decks, and finding that same functionality and some new benefits as well, because we're moving into this nice file-based workflow, and tape is kind of leaving us. Say a little prayer. I like tape. So that's kind of the Key Pro line, and just a little bit about where we're coming from with this. So we're starting to talk about 4K, and in particular, we're talking about the C500 camera, but a lot of what I'm going to talk about applies to all of the 4K workflows that we'd see out there. But the C500 was one of the first cameras to kind of really tackle this interesting, I don't want to call it a problem, but situation where it's able to output raw information. The Red camera obviously did a lot for getting people into the 4K workflows, but it didn't have a raw output on it. This is really the first camera that had this raw spigot that we could take the raw data and do stuff with. The interesting thing with raw data is it's big, and it's kind of interesting to deal with. So you've got some interesting situations that can happen with something like a 4K camera. And as Andy was mentioning, and I don't want to drill this same graphic that everybody's seen 100 times, but 4K is big, right? It's really big. We're talking about 4 times the number of pixels, and there's all the different aspect ratios and resolutions and frame rates, and you guys have all got briefed on that, so thankfully I don't have to go into that. Thank you. But just know that we're talking about a lot of data here. This is big images. They look great. They're a lot of fun to work with because you have fantastic resolution. But let's just put this into perspective for a second, right? And I promise I'll keep the charts and graphs to a minimum. There will be no math on the test. But a 10-bit RGB, 24 frames per second signal, right? In good old standard def, we were looking at a data rate, this is uncompressed, of about 42 megabytes or megabits per second. All right, not too bad. When we moved to HD, we're up to 199 megabytes per second. Now we're starting to, get up there a little bit, but you can tell where this is going, right? There's 4K, right? 4 times HD, 796 megabytes per second, right? On an uncompressed 10-bit RGB. So that's a lot of data to have to move around. Look at it a different way. Let's look at it at the amount of storage space that you're going to need for this, right? So back in SD, 2.6 gigabytes for 1 minute of SD video, uncompressed 10-bit RGB, right? HD, 12 gig per minute. Uncompressed 4K, 48 gigabytes per minute of storage space. So that's a lot of drive space that you're going to need. So what would help with this? Well, what if instead of using uncompressed 10-bit, we went to a 10-bit 4K ProRes compressed file? Now we're talking about data rates back down in the 9, or this is storage rates actually, but the data rates are comparable, right? 9 gigabytes per minute. So we're back into the realm of HD data rates, uncompressed HD data rates. This is something that now is actually possible on my laptop. And if you guys come out afterwards, we're showing this whole workflow right outside with the camera and the quad and the whole thing. Check it out. It's pretty amazing. You don't have to necessarily have a supercomputer to be working in 4K. So back to our Canon C500 camera, and the interesting way that this allows us to work is, what if we take that same principle for KeyPro and apply it to 4K? And we get the KeyPro Quad, right? 4K capable KeyPro recorder that records into a format that you can use right in your edit. Matter of fact, it's a QuickTime file. You can just play it back right inside QuickTime Player. So suddenly you've got access to data and 4K resolution frames at a more modest rate and a more modest storage size. So a couple stats on the KeyPro Quad. And it's important to point out, we're talking about a 4K and Quad HD, which has now kind of become Ultra HD or UHD. You may see those terms kind of thrown around too. But that's basically those 4 HD resolution frames that make up a true, what are we calling it, 4K image? Ultra HD. We'll follow the marketing. But this recorder will do HD as well in 2K right now. So it's something that you can use now for HD projects, and as you move into 4K projects and want to start dipping your toe into that water, this is a device that can move with you for that. So it's not just a 4K recorder. You can use it now and then move into the future. Supports 444 color space. That's another thing that we were talking about, those higher color spaces for better color reproduction. And then also the monitoring side of it. We can monitor full 4K out of this device, and we can also downscale that to HD, and we have an SDI and an HDMI port on the back. And I was going to bring my little prop in with me, but come back outside and see it. We got a bunch of them you can get your hands on. The other interesting part of this is you start to connect it up. Oh, thank you, Jay.
Somebody's listening.
My lovely assistant, Jay. So, yeah, a bunch of ports on the back of this. I don't know if you can kind of catch that, but full 4K in, 4K out, HDMI and SDI out, downres to HD resolutions, as well as a bunch of other connectivity for Ethernet and things like that that you can use to control it. Really easy front panel controls, so it's pretty straightforward. Like I always say, guess which ones record, right? That's pretty obvious. But getting back to our raw workflow here. So with something like the C500, we can take a single raw data stream that's coming out of the camera, and it's fed over the SDI connection. So it's fed over what would normally be a baseband video signal, but it's actually just raw data plugged into that and being moved across as a transport mechanism. We get that raw data, and then we have to actually turn it into an RGB image, and that's what the KeyPro Quad does in real time, takes that and does a debayering process on it to turn it into an RGB image. Then we can record that as ProRes onto a removable drive, 4K. We can also pass that raw data out and record that on a separate drive system and computer for just recording the straight raw data. So you've got that workflow as well, and the full monitoring capabilities. Once you get the drives out, and these are our AJ pack drives, they're a reinforced drive case with a connector that's a reinforced connector, so you can stick it in and out a bunch of times. It's not a bare drive, it's actually encased in something. So it's really sturdy, made out of metal, goes into a dock that then connects through either Thunderbolt or USB 3 to a computer, and that's how you get your files over. So really easy to just pull that out, stick it into the dock, drop your files into whatever program you want to start editing with. So just to kind of recap that all, because I really like to just point out all the stuff that this thing is doing. 4K RAW being debayered, turned into ProRes files on a removable drive. We're also passing 4K RAW over Thunderbolt to a drive and computer that we can then record and process all that raw data. So from a workflow standpoint, you've got your ProRes, and if that's what you want to work with and that's you're going to be your deliverable, you're good to go. You can still record this raw data so that you have that option of going back later and processing it, turning it into something else if you need to access that extra color space and that extra flexibility that raw data gives you. You have that option. There's a lot of people that are going to want to work with RAW. They want that purity of image quality. So you've got that option as well. 4K monitoring, full 4K out, as well as simultaneous SDI and HDMI downscaled outputs for HD monitoring. All that's happening simultaneously, all in real time, all on this one little box right here. So it's a lot of functionality for one little guy to be able to handle, but those are the kind of things that you're going to need to do. This really becomes the hub of your production. You can be doing all of your monitoring, playback. Once I've recorded something, I can actually hit play on this, play it right back to my HD monitors, my 4K monitors, check everything before I move on. And one last one here, I think, is the price, $39.95. So that's a lot of functionality and not a lot of money, and Michael's got a question.
Obviously you can capture baseband.
Yes.
You showed that you could capture Canon RAW. What other codecs can it capture in transcoded ProRes?
Can you repeat the question just for
Yeah, so the question is, in addition to baseband video, which we can capture, raw data, what other signals can we capture in and turn into ProRes files?
Yes.
Is that the question?
Yeah,
Okay.
other codecs. Basically.
Other codecs?
Yeah.
Right now, it's recording only ProRes.
What
So-
other ones can you source? You source Canon RAW.
Oh, okay, yeah, Canon RAW and baseband video are the two that we're supporting right now.
Okay.
Yeah,
Is there any roadmap for other codecs to be captured?
potentially, yes.
He's asking if it's going to be Ari Ross certified or if it's going to be Sony 4K.
Yeah, and they're all things that we're looking at. I obviously can't say yes or no right now, but we are looking at it. You know, it is a possibility, but we'll have to see where it goes. Yeah.
What are the size of the SSD packs? What do they come in? What are the price of the SSD packs? And what's the time that they hold?
Sure. So size, price, and capacity of the SSD pack drives. We have a 256 gig capacity and a 512 gig capacity. The 256 gig one, I believe, is $695 US MSRP, and then the 512 is $1295. So just about double the price.
And what does it hold in if you're recording Canon RAW?
We're not recording RAW onto the drives. Only ProRes is recorded onto the drives right now. Yep.
What will a 256 hold?
Yeah, 256 will hold about, I believe, 30 minutes, 35 minutes, 25 minutes. I can look on the AJ data calculator.
Is it in the new data calculator?
It is. Yeah, the data calculator has 4K in it. So this is the worst demo ever. Let me play with my phone. So let's say we go for 35 minutes. Yeah, so on a 256 gig, we're looking at probably about closer to 25 or 30 minutes, I would say, on something like that. Yeah.
It's 9 gigs a minute,
Yep.
and it's 256,
Yep.
so it's going to be a little bit over 25.
Yeah, you're looking at about 24, 25 minutes, and then just double that for the 512.
And is the 4,000 price coming with any packs, or that's?
No, that's just for the unit itself.
And what about the dock? What's the price of the dock?
That's an excellent question. I'll have to get some more information. I don't have it on the top of my head.
Are you discontinuing your original Tegra?
Nope. No,
Well,
it's
just to
still
repeat the
still for
question,
sale. Oh yeah, sorry, discontinuing the original Key Pro.
All the Key Pro models are still shipping units.
Yep.
Is it one SSD drive?
Okay, yeah. Is it one SSD drive? There's 2 slots in the top, so you can have 2 drives in simultaneously. And then when one fills up, you have to right now manually switch it over to the second drive. But rollover is the question that everybody asks, and we know about it, and it's something that we're looking at for a future release. Being able to automatically basically roll over to the second drive once you fill up the first one.
Can you do simultaneous dual recording?
Not yet, but that's the second question that everybody always
The other
asks.
question was
Simultaneous record on both drives, so basically the same thing recording onto both drives, so you have redundancy. And that's, again, something that we are looking at being able to do, but not in the first release. Yes?
I wanted to make sure I understood on the flow chart. You can record all 3 formats at the same time.
Just
Just wanted to check on
Yeah. So we can record the 4K ProRes. We pass the 4K RAW through, so we're not actually recording that on the unit. We're recording it on the drives here.
separate recorder that's happening.
Yeah.
And the 4K and the HD.
Yeah, these are monitoring outputs. Yeah, yeah. Yep.
So just so
so everyone at home, tuning in can understand, the same time the KeyPro Quad will record in 4K ProRes, all the outputs, debared 4K, scaled HD, and 4K RAW are all available and active if you wanted to hook up secondary recorders to also record that material.
Yes. Yeah.
Yeah, you could,
Yeah,
you could very well put a
KeyPro rack off of this and record your HD signal.
You could take a
that.
KeyPro Mini to have that for offline editing, I guess, possibly.
Right. Absolutely. Yeah, question back there.
I was going to say, so if you have 2 slots, could you have a dual record where you just do the HD recording and then the 4:4 recording on the other slot?
Right, so the question is, if with the 2 slots, could we do a 4K record on one slot and an HD record on the other? Potentially, yes, but we don't know if that's actually going to be possible, but it's a potential. Exactly. Yeah, it's just a question of data rates and wiring and engineering. Yes?
The 4K RAW pass-through, what is that coming out of it?
Yeah, good point. Thank you for reminding me. The 4K RAW that's coming out here is actually over Thunderbolt. So there's a Thunderbolt connection on the back here. And you just plug the Thunderbolt cable in, come into a drive array, loop over to a computer. You do need both a computer and a drive array. You can't just plug a drive array into this. It has to have a host computer that's actually driving it. But then that 4K data is passed through and you can just record it as the Canon, I can't remember the file extension.
Well, Canon RAW files.
Canon RAW files, but there's, whatever their file extension is on that. Yes?
So is there a way to get the 4K? We know one of the other manufacturers can record the Canon RAW, the Convergent.
Mm-hmm.
Is there a way to get, if you took the signal out of the camera into that, is there an output that would give you the RAW to that recorder, that if you wanted to mount your recorder and a Convergent, a Gemini 444, that you could record, RAW and your ProRes at the same time?
That's a good question. No,
I think that's a question for the other
Well, but you're
manufacturer,
asking specifically about, do we have any way of outputting the raw data other than this Thunderbolt connection, right? And I believe the answer to that is no, not at this time.
It's called a DA.
Yes.
Well, actually, I mean,
that's called your
the
cart.
two.
Exactly.
Can they both be?
Yeah, because both ports on the Canon camera.
Right, that's true.
Output the 3. They both put out one 3G outputs the Canon RAW. So you could use the other 3G to theoretically output to different recorders.
In theory, you could actually have the 2 outputs from the Canon camera feed 2 different recorders in that way.
Yeah, you could. Yeah, it's really interesting. I have a question, sorry. What other baseband signals can you record? And what are your frame rate limitations on those?
Yeah.
Both in 4K and lower,
What other baseband signals can we record and frame rate limitations? So it's standard baseband, so we can do the 3840 quad or ultra HD over 4 SDI connections. So we have that capability. We can go up to the full 4K because they are 3G connections on the back. All 4 of them are 3G connections. So we can handle all the way up to a full proper 4K, 4096 by 2180, 2160, sorry.
Says to me right now that you could record the 4 output HD SDI feed off the Sony F55.
That's correct. Yep. We haven't tested it yet, but we anticipate that it's going to plug right in and work fine. And we've worked with Sony to have commands such as automatically starting the record. That's another aspect of this is through metadata inside this RAW channel or inside baseband video, these cameras are sending out signals whenever they start and stop recording, and we read that so that if you hit the start-stop button on the camera, it will start and stop the KeyPro Quad as well. So it's just one less thing that you have to worry about. But I forgot where I was going with that, sorry.
Other record formats.
Other record formats, thank you.
Lower
Okay,
Yeah, so we can go down to, again, 2K or HD. As far as frame rate limitations, at 4K, I believe we're able to go up to 30 frames per second. And then at 2K, we can go up to 60 frames per second. So we can handle that all over the standard.
And 444?
Yes.
Okay.
Yeah, all in 444.
Okay.
I just had a quick question about the 4K RAW recording with the array. Does that automatically record, or do you have to go to the computer and press record?
That one you will actually have to start recording on. I believe you'll have to start and stop recording on the software that's running on the computer, because that data stream is just continuously coming in, and I don't believe there's anything that's set up to read that start-stop data across the Thunderbolt.
But that is just software, so it doesn't
is.
mean a plugin could be written easy enough to look for the flag.
Potentially, yeah. Yeah. The other thing is that Ethernet port that's on here, you can configure and control the KeyPro Quad from a web browser on that computer as well. So it's fairly easy to be able to start and stop and configure stuff remotely. You don't have to be in front of the unit, which on set can be helpful. Yeah.
How are the files named? Are they is that controlled in the KeyPro Quad, or is it controlled by the camera?
How are the
files that you're actually recording, like the ProRes files? How are they named? Is it named scene intake by the operator that inputs
yeah,
that,
the naming is done on our device, and I'm trying to remember if that data is actually in the Canon. If it's in this raw signal here, then we'll take whatever name they're giving us. But I don't know if Canon's actually embedding that information in the raw signal. They are? So our files will be named whatever is set on the camera. Yes? I have 3 questions. One question in 37 parts.
So you were talking about the SSD. Is that a proprietary SSD, or is that something I can source from Samsung? What do you use?
It's a proprietary SSD. It's our drive pack that we make and sell.
And how heavy is the unit?
I believe it's like 2.2 pounds, maybe, not even, pound and a half. I can hand this to you. It's really light.
Okay. Yeah, I'll take it. And last one, I promise. In your opinion, how easy is it to see the screen in direct sunlight?
That's a great question. I haven't used it in direct sunlight yet, so I can't say. But yeah, I believe we're going to have a little hood that you can put over there, so you'll get a little indirect or a little coverage over the screen. But yeah, it's a good question. I don't know. Yeah.
Do you know how much power it requires?
Not off the top of my head, but I can find out for you afterwards.
Yeah, how do you power it? What's the connection?
Yeah, it's a 4-pin XLR on the bottom. It's a standard 4-pin. You can power it off of a battery pack, or we've got an AC adapter, so you can plug it in through that. And same mounting plate as well. Like the side profile on this is exactly the same as our KeyPro Mini. So the mounting plate and the rod adapters and stuff like the Zacuto Swiss plate will just bolt right on and work with this as well. So a lot of the stuff that was built for KeyPro Mini will work with that as well.
Any other questions? Oh, one last question from Lou. Can't help himself.
So close.
Yeah, sorry. Well, actually, two. What's the resolution of the screen, the onboard screen? Mm-hmm. And secondly, obviously, debayering techniques, algorithms, have an effect on what the picture quality is. Mm-hmm. Have you done comparison of your real-time debayering to, software debayering from some of the systems that are known to do better debayering than real-time?
Yeah, we worked with Canon pretty closely when we were developing this and checked our debayering against the debayering that the camera does and other sources, and we're dead on. I mean, it was a perfect match.
And the screen resolution?
Yeah, screen resolution, again, I don't know it off the top of my head, sorry, but not 4K.
It's a confidence screen, I guess.
It is. It's really, it's a confidence monitor. It's designed so that you can see the signal that you're getting in. But I can get you the exact specifics.
It's pretty tiny.
Swing by.
Yep. It's a small screen. So, thank you very much.
Thanks.
Thank you. And we want everyone to know that this is what we're here for. So we let each manufacturer take the time that we need to take. That's what this is about. We had lots of questions for AJA, and now we're going to transition over to Atomos. And Atomos, unfortunately, could not be here tonight. The representatives cannot be here, so it's going to become the Mitch and Andy show. As I'm going to go run out and grab a couple of little bits and pieces, and Andy will start the little presentation from Atomos, and we'll just show some toys, as it were.
I'll have to make it
right back, sir.
Can you cap the shutter? I'm going to bring it over to the way. So I have a little presentation they gave us. This is a nice presentation they gave us. So we'll give it a good college try here. Support Atomos and their help. And they're at the final cut. There's a super meet this weekend. Tonight apparently they're all there. So they send their love, and affection. You know, I'm just going to go ahead and
I'll be right back.
do this here one second,
this thing in
and then I'll be good to go. So you forgive me while I get this up and going. So, all right, whenever you're ready, Jeff, you can go back to that. Thanks, Atomos. Smart production photographer. There we go. Cool. So, you know, we got the latest firmware builds on these things, so we can talk about it right away. You know, one of the interesting things, I guess Mitch is talking in here. Yeah. Awesome, that was me. One of the interesting things about the Ninja and the Samurai, the two recorders from Atomos, is sort of their size and weight. So one of the first things you do with these things is you'll go pick it up and feel how light it is. It's very impressively light. They're just, you know, we like them a lot on any camera that's meant to be handheld because they are so light. So we're big fans of that for sure. So we have the two different models, and Mitch is going to go get them, but I'll go ahead and just go get started here. You know, this is their slideshow, so we'll just kind of get through different pieces. But you know, we talk a lot about this stuff already about formats and compression. But you know, here you just see that a lot of cameras have a lot lower compression. You know, like what you have on a DSLR up to even an ENG camera. They're all fairly compressed formats. We know this because they're meant to give you a lot of time on the recording, right? So Atomos says, well, if you got an HDSDI camera, we got a recorder for you. If you got an HDMI camera, we got a recorder for you too that can improve the quality of all of these formats, right? So we have the two recorders, the Samurai and the Ninja 2. The original Ninja has been replaced by the Ninja 2 with a lot of improvements over it. The Samurai here has the SDI spigots, as you can see, right, in and out, and the Ninja 2 is an HDMI only recorder. Ninja 2 being so lightweight and small, you can see it being very popular with the SLR crowd, especially as the 5D3 adds their clean output option. So this is a nice option being a small, inexpensive recorder. So also on these guys, and this is a marketing presentation, so you'll get the prices right away. You see the price points, you know. Mitch has got them. He's got it together. So we got some props. There they are. So the Samurai and the Ninja both feature some nice options, which I'm a big fan of scopes and modes and new options in these recorders. So they've actually been improving the firmware over time to add in some cool things like focus peaking, zebra, false colors, blue only. So not only are they producing a recorder, they're also a small little monitor, which is an advantage of a lot of these little recorders is they have monitor features. So it's sort of 2-in-1. There's Mitch. Look at that. Hello. So you see these options here, blue only, false colors, zebras, focus peaking. These are great things to have. They both record both ProRes and Avid DNX at these various flavors. So we saw the things before when I was going over them. The HQ mode of ProRes up to 220 down to LT, and then Avid DNX from 220 all the way down to their the 145, 115, I guess, lowest quality, which is an 8-bit format. But you have all the formats that you need, and like Mitch said, it's all sometimes just about what you deliver, right? So they try to give you all those formats. They took them a while to get here, but they've recently added all these formats, and they're all working. We did some testing with it, and we've had results that we expect. So ProRes and Avid DNX on both the Ninja and the Samurai. Again, the difference being Samurai SDI, Ninja HDMI. It is a touchscreen interface, right? I'm just keeping going through here, Mitch. So you can jump in whenever you come with it.
Yeah, I'm sitting here touching the screen to actually get through the different menu pieces of the way you can control this.
Exactly. It is a total touchscreen, obviously. Record, playback. There is a monitor mode, the confidence monitor. You can see what's coming in. Menu for all your lower settings, and the record button. Go figure. So it's very simple to use, very easy to set up. It does record in all those recording modes. It does have 2-3 removal. I think I have some more pieces here. Let's see. Yeah, there we go. It does tell you your video input there in the top corner. It has your recording settings there, your battery life indicator in the top. And note right away, it does offer a 3-2 pull down removal. We talked about that before, right?
But
so there, yeah.
You need to tell
the
glory of how it
they
determines
do it.
your 2-3 pull down removal.
How they do it. It's interesting. This is a really funny story. Actually, the C100 there, Canon camera with the Ninja on it. I had a client came in. He said, Andy, I got the C100. I love it. I love my little recorder that goes with it. But I put the 2-3 removal on, and sometimes it works, sometimes it doesn't. I don't know what you're talking about. Sometimes it works. Sometimes I'm looking at the camera and it starts to work, and then sometimes I switch modes and it's not working anymore. It doesn't do the removal anymore. And so if you read the manual for the Ninja, it tells you one thing, which is to wave your hand in front of the camera when you go to 2-3 removal mode.
Literally.
And why do you think that is? To wave your hand, the wave your hand trick. Well, it's because it's determining the pull down, right? Yeah, it's figuring out the pull down removal by seeing your hand move. Remember that pull down removal cycle looks for the.
What's literally happening is that the camera is recording, say, 24 frame or 2397.
2376.
And yet the HDMI signal, because it has to abide by
standard
what
HDMI.
Is the standard for delivery over HDMI, and that standard is 60i, or actually 5997. And so it takes each frame and it says, I'm going to do 2 fields, then I'm going to do 3 fields, then I'm going to do 2 fields, I'm going to do 3 fields. And that builds out to turn your 24p into a 60i. That's how it just fills that out.
It's that 2-3 removal we saw.
And so 2-3 removal is to take out those extras and be able to get you back to what was the true 24p or 2397 actual original signal, which is what you can record in the recorder. It is the exact same thing that the camera actually is capturing. It just, they had to fill in all this extra stuff. Well, how does the recorder know? And the way it knows is it looks to see like this movement, and it sees, all right, well, that kind of repeated twice, and this one didn't, and there's only like 5 things, and then it repeats over, and so it can kind of look at it and say, all right, well, that's the pattern I see, and now I know where it starts.
And then it removes it.
But it has to have movement.
I mean, other recorders do this as well, and they don't necessarily need to do that. But I mean, I think it's a really clever idea. And really, but what's happening for the client was he was literally not putting his hand in front of the camera when he moved the mode. So really interesting. Yes.
Is this something you have to do once when you turn the camera on in the day?
Well, when you go to playback mode,
the question is, how often do you have to do this?
Yeah.
And the answer is when the camera is basically when the camera's turned on.
Yeah.
And once you start, and once it's on, not even whether you're recording or not, but once it's just on, as long as you keep going without interrupting things, not like not a power change.
Or if you go to record playback mode, it'll
right,
you have to
if you went
redo
into playback and then you have to go back to record.
Then you have to do
those
it again.
things are going to be what interrupts the flow.
These are the things we find interesting here at AbelCine. Just
exactly.
wave your hand.
And you can say it's a limitation of the system, but if this is how you're using the machine, if the way you're using the machine is to do like a series of shots, and you're not going to ever really be stopping and I'm going to play this whole thing back. I'm going to see what it looks like, or I'm going to shut down. And if you're not doing that, those changes. Doesn't make a difference. I mean, you're going to set up and then it's just going to go and you're never going to have a problem.
Yeah.
But if you are going to be stopping and starting in certain ways and breaking it up like that, then it's something to consider. Every tool has its sweet spot, if you will.
So it does do that. Very interesting. We like that kind of thing. It does have, by the way, on the back of it, it has 2 Sony L batteries, which you see in the back there. They use one at a time though, so it'll just keep going. It doesn't use them both at the same time. It'll drain one and then go to the next. Right. You can also power off of PTAP, little piece that comes with the unit.
Yeah, I didn't bring them in here, but it's a tiny little box, a little adapter. It's basically a pass-through because these can handle a range of power.
Right.
So they have an AC power supply. They also have running it off of a little adapter, so you can run it off PTAP power.
Yeah, that's right.
And this one is the Ninja 2, and just while I'm standing here and blabbering away, this one, which is a slightly larger unit, slightly bigger screen, is the Samurai. This is the one with the HD SDI. When the screen looks dark because I was pointing at a dark corner, but they have the exact same interface to use. The drives are the same. It's on the back. You see it has the same battery mount and stuff. It's Just one is physically slightly larger than the other because
SDI.
Because of SDI, it needed to be bigger inside. It had other stuff it had to do, so they had to make one a little bit bigger, and that's why it cost a little bit more.
Yeah. It does take timecode over SDI, as you can see there. You can run timecode to come off the source that way, or you can have you can program timecode in, and it will trigger off that timecode, or it'll trigger off of Sony, Canon, Arri, Red, and a couple other cameras.
Yeah, it pretty much
triggers off
follows everything.
all the naming off the SDI triggers.
Right. Like the Epic, the Red Epic was one of those
first
cameras that was always difficult for because that camera wasn't designed to have like an outboard recorder. They were kind of expecting you to use the internal recording. So all the recorder manufacturers had to catch up on that one. That was the tough one because they had to like interpret that signal. But it does it now, and so do others as well.
Yeah. Record time indicator. It's on the hard disk, and it does. I'll talk about the hard disk in a second. You can rename the unit if you want to. There's just actually the name of it. Audio channels, up to 12 embedded channels, but really, or you can do on the side of it, there is an audio input jack, which is a two channel off of a mini jack as well, if you want to do that analog. And there's the trigger option, which is off the time code of the file name. So those are your options on the side there. This is the other thing they bring up, and they say it's the only device that can record affordable spinning disk media. Whether we do or don't agree with this idea, they have tested it extensively with spinning disk drives and had really good results. And honestly, a spinning disk drive is much less expensive than an SSD. So, the thought process there is that you could just buy an off-the-shelf spinning disk, put it in their little caddy, which is a small box you'll see in a second, and then go to town.
I mean, if you think about a lot of the work we all do can be fairly meat and potatoes of, sit-down interviews with people or on a tripod and just fairly sedate camera motion situations that are not going to be particularly taxing to a hard drive. Yeah. And so the thought is, well, look, I can buy a hard drive for pennies, and I can, at the end of the job, that I just like tape. I can back to tape. I can hand it to my client and say, here, there you go. There's your media that just pull it out of the little caddy. There you go. There are others who are like, I'm not touching spinning media. I'm staying away. There is no way. I want solid state all the way. I don't trust it. I don't want to get near it. I don't like it in my laptop. I don't get it away from me. Yeah. And so then you can instead use an SSD, and then you have a confidence with that.
Same interface. Obviously, just an idea.
One slides in the slot just as easy as the other.
I mean, we have back and forth there. We've all had experiences one way or the other. You make the judgments. When you SSD, obviously, for high vibration, mission critical shots. Right. Every shot I do is mission critical, though. No, I'm just kidding. Yeah. Not every shot is mission critical. It comes to actually a really nice little case, and you have the caddy, you have the batteries with it and different wall adapters. It comes with a USB 3 and Fireway 100 download station for it. There's the Ninja itself. These little caddy cases, this is where you put the SSD or the spinning disk into it, and they're cheap. You can get a bunch more.
I think they're like $17.
They're basically
just ridiculously cheap.
It's a piece of plastic you wrap around it just to make sure it stays intact, and some other accessories come along with it, including the cables. It's a nice little kit. It really is, and And to go along with it, in case you wanted to buy one unit and not, if you wanted to buy just an SDI version, but you wanted HDMI option or vice versa, they have this little box called the Connect. You can see it in my
hand just as much as you can see it in the hand on the screen.
Big picture there,
These are converters. These really became popular when all the HDSLR cameras came around. Everyone was like, suddenly I got a HDSDI and HDMI, and how do I get from one to the other and stuff? Well, they've come out with these ridiculously tiny, very inexpensive, but extremely capable little converters. And there's two of them because one goes from HDSDI to HDMI, and the other goes the other direction, HDMI to HDSDI. And you can see they're the size and shape of a little battery because they actually will fit onto the battery slot on the back of these units. You can use them on their own. We use them for other things as well. Yeah. But they'll fit right onto there, and then you can put a battery right on the back, and it'll pass power. It'll power this as well as power the recorder, so it'll pass that right through. They also have a little adapter so you can use PTAP, and so that's a higher voltage, and this can doesn't
and it has a battery in it too, right?
Right, it'll pass that through and it'll power that. Or it actually, this guy is running right now. I thought I was charging it. Well,
I think it wasn't enough
I'll put the battery back on here, but it was charging. Oh, there it goes. It lights back up. There's a battery inside here that lasts for about an hour on its own. So if you need to, do whatever, it'll power this. It won't also power that. But it has a bunch of different modes in each of them where it outputs a bunch of test signals.
It does test generation. It also does pull down removal in it.
Right. This will have the pull down removal. We have a wireless video system that we figured out, and it passed every possible signal from one to the other.
It's very good. Yeah.
It all worked.
It's a great little converter box.
Went through and stuff. So it was really pretty capable little devices. So they're just for $349 they answer a lot of little problems for you.
Yeah.
And they have it's a tiny little box that you can just switch modes just by pushing these little buttons through, and you get all the various test pattern generations and tones.
It's very useful to have
stuff like that. And of course, my favorite mode is when I push the buttons together. It's a flashlight.
Flashlight mode.
But you're trying to find your tools and stuff. You have to flashlight mode. So
hey, whatever. It's pretty awesome. I don't know.
I've actually used it in its flashlight mode. I actually had to.
Cool.
So it's
that's just funny. It's just it's that Australian sense of humor. It's a flashlight also.
Yeah. And it's a flashlight. So these are the Connect boxes, what they're called.
Yeah, they're really cool. Yeah.
S to H or Connect H to S.
And then 340. There you go. 349. There it is.
349 plus tax.
Plus tax. There you go. It said 2.3, 2.2 removal, stackable module, continuous power. Even includes a flashlight.
Right. So yeah, you can see a lot of connectivity does a bunch of things for you.
Test patterns are nice. You have a couple of options there too. So hey, it's pretty cool. And that's pretty much the little presentation. It was condensed, but we can answer that. We pretty much know pretty well, and Jeff knows it pretty well too. So we can answer questions about it. Please, anything about these two products.
Questions?
Yes.
Could you just run down the prices of the solid state versus the spinning disk media and the capacities and so forth?
Well, it uses consumer drives. So you can use, readily available industry drives.
Like SanDisk
you
drives
can
out there,
certainly discuss it with our representative from SanDisk. The products he has on sale for you today. But I read these numbers a while back. I think you're paying like 25 cents a gig or some number like that for an average hard drive, whereas you're paying a dollar a gig, is it now? It's right at about $1 a gig for an SSD.
For 512 SSD.
For a 512, that sounds about right. So about around $1 a gig. So you can see the savings. I mean, in fact, there are some hard drives that are really down there in price, and I'd be a little nervous about using them. But that you can get them down to something like 6 or 7 cents a gig kind of thing. With a certain size, I'd be, at a certain point, I'm like, well, I'm willing to.
It is your footage. It
is my media.
Yeah,
everything else is like a waste of time if I don't record it.
Yeah.
So, but obviously hard drives are just ridiculously cheap in that regard because it's just you just spit them out. Everybody uses them for a million things. Yeah, and SSDs have dropped dramatically in prices
comparatively
from when they came about originally. This type of media, and most of our recorders here are recording to SSD type media that even the proprietary ones are getting quite reasonably priced, so that you have when some of this technology was first introduced, you would be $10 a gig, sometimes $15 a gig for some of the media. Now you're getting stuff down into the $1 a gig, maybe $5 a gig for some of the proprietary things. It's not so extreme. It's not stuff that like, oh my God, I can't even pay this much money for quadruple the cost of my recorder. It's not quite that way anymore. Now it's gotten to a much more reasonable level. Not maybe to the point of tape where he's like, well, I'm just going to leave everything on this card and I'll just buy another card to fill up again or give that to my client.
It could get there though.
There's some things that you do that with people, but in general, these larger memory capacity devices have gotten down in price so low that it's not a make or break thing to even consider investing in them.
I agree.
More questions?
Ninja Samurai. Check them out. They're out there on the far table. We'll have them out there, and we can answer questions about them out there afterwards.
So Atomos, very happy to have them here.
Thank you guys.
Lots of versatility with their devices, and also a lot of great price for performance.
Absolutely. Price performance is
coming out of Atomos is very convenient in that way.
Yeah.
And our next manufacturer is Convergent Design. We have
yes,
gone
Dan
to letter
Keaton.
C.
The venerable
And
Dan
that is
Keaton.
Dan Keaton
We
from
love Dan
Convergent
Keaton.
Design will
I
be
want to tell you what, I
discussing
love Dan
his
Keaton.
lovely products. And up he comes, and Andy's going to find that presentation inside that computer somewhere.
That's right here on the desktop here. I put it here on the desktop for you, Dan. So
dig. He's got to find it. That's why the screen went blank for a moment, and I'll just do the little song and dance while we're
just switch
waiting
right
for that
over.
to show up.
We'll
Come on,
switch right over.
Let's make that happen.
I'm right there with you.
While we're waiting.
Yes.
What test patterns is
Yeah, use this one right here, and just hit the red button.
You know what? I can't remember all the various test patterns off the top of my head, but I do have a whole. It's in the manual, which is available online, and I can show it to you. I have all that material here. It actually is a whole series. We can hook it up to a monitor and we can look, because it's pretty cool. I think there's something like 6 or 7 combinations that it offers, including tone, and you have like graduated grayscale. So you have the brightness range, and you have IBU and the various your standard test patternings. How you doing, Andy? Almost up there? And Dan Keaton, everyone.
Hello. What I'd like to do is ask some questions. You've got something?
Yep, there you are.
Hey, very easy. What I wanted to do was, who likes dessert first? Can you guys hear me? Who likes dessert first? One. Okay, well, why don't we go directly into questions and answers? So I'll ask the first question. Who knows about the Gemini? It's been out for a year. Do we have a bunch of people that don't know about the Gemini? Okay. The Gemini is a high-definition, full uncompressed video recorder. Plus, in the next few months, we're going to be adding Avid DNX HD free to make it a compressed recorder. And we may add more codecs later. But we've announced Avid DNX HD so that you can buy our moderately expensive recorder and use it for full uncompressed when you need to, and use it for compressed for everyday work. We have a 5-inch monitor on it. It's a high-quality monitor. What's beautiful about our monitor is that you can watch it from any angle. It's not one of these monitors that you have to look straight at it in order to see. You can turn it at any angle, and you'll still be able to see. So it's a high-quality monitor. It's a resolution that's good enough for watching HD, and of course there's a 1:1 pixel mode. So just in general, we're a high-quality, full uncompressed recorder, but then we add extra options. If you need to work with an Alexa camera, we can record the native HD out of the Alexa or ARRI RAW. I was speaking with a gentleman a little while ago, and he made a very important point that if you're recording RAW, it doesn't matter what recording or recorder you're working with. For example, all Alexa ARRI RAW recorders are certified by ARRI. So if you use a Codex Digital or an S2 recorder or an Astro Design recorder, they all record the exact same data. You don't get a better quality ARRI RAW recording by buying a more expensive recorder. They're all the same. So someone says, well, what about the metadata? If I buy a more expensive recorder, won't I get more of the metadata from the camera? No, that's also a part of the ARRI RAW certification process. So the output of our recorder or any other ARRI RAW recorder is essentially identical. And when I say essentially, we add some stuff, some extra metadata in there. One of the things that we added was the serial number of the SSD that we recorded the file on. Let's say you get to post. Now this hasn't happened, but let's say you get to post and someone sees a corrupt file. Well, what they would want to know, well, how did this happen? Okay, well, on every frame, we put the serial number of the SSD. And then when you put an SSD into a Gemini, what you see is a serial number. So you can trace it back to a particular SSD, and at the very minimum, segregate that SSD out until you prove that it's perfect. So that's just one of the little extra pieces that we put in. Now, any questions so far? Okay, we have a dead audience. Okay, which way do I go? Okay. I was pressed in the middle. Damn this technology. Okay, it's a versatile, field-proven, professional video recorder. And I'll show you what I mean by that shortly. You can record HD, you can record 2K, with options. You can record Area Raw, Canon C500 4K, or Quad HD, or 4K half raw, or all the other modes that the Canon C500 creates. And we're also a 3D recorder. Again, that's another option. For 3D, not only do we record from 2 cameras, we do all the 3D combining functions. So 3D is not a very popular thing today, but there may be some features that are still going to come out in 3D. One of the things you need to do if you're shooting 3D is align the cameras. Okay, so you would like to see the 2 images combined together. One of them would be a 50-50 composite. One of them would be left minus right luma, or right minus left luma, or maybe you want to watch it in anaglyph mode. Anaglyph mode is not something you want to record in, but it's very handy if you're a cinematographer and you want to see what your divergence or convergence of the 2 cameras are. If you see it in anaglyph mode, where you see red and blue, you will be able to determine instantly, oh, I don't have my glasses on, but I can still see the 3D effect and how much of it is. So we have all these 3D combining functions built into the Gemini. Again, it's an extra cost option. Now, the Gemini is not an inexpensive recorder. It's $5,995. The media cost is also not inexpensive. It's moderate cost. Now, our chief competition is codecs. Okay? They have been in this industry for a long time, and we come in, and we've been very successful in this market. There are a lot of movies that have been shot with Area Raw, and we have a very high acceptance with the C500 camera. One of the things we have is moderate media cost. It is overall very economical compared to the other media out on the market. Now, some people say that our media is proprietary. And if you look at it in one aspect, people would say, yeah, it's proprietary. Look at it in another area, it's not proprietary. We use an SSD. It's 1.8 inch. It's built by one of the leading SSD manufacturers. And we don't do anything to that media other than to thoroughly test it. We get the media in, we test it, and we test it, and we test it. And we don't write a whole lot to it. We write enough to it to prove that it can read and write. And then we read from it. And then we get it real hot. And we get it cold. And we run it continuously in a read mode, so we're not harming or not wearing it out. But the goal is to prove that it is professional media. So we go through this evaluation process, and we weed out the ones that are not fast enough, and we eat those, okay? But our perspective is we don't want anybody going out on set and have media that is not up to the task and use it and then blame our recorder, because they would, and it's only natural. What failed? It would have been the Gemini that failed, but it may have been caused by the media. So we try to make sure that our media is as professional as possible and it's fully tested so that we don't have a lot of media failures in the field. Here's some movies. This is just a very limited list of movies that we know about that the Gemini has been recorded on. The Tomb, okay? Sylvester Stallone, Arnold Schwarzenegger. It's about a $70 million movie. It was shot mainly in New Orleans. It's a very interesting movie in that it was shot not in area raw, but in HD. The director wanted to shoot in HD, so the Post House said, okay, and we said, okay. And so they used 3 Alexas, and they shot in HD, and the Geminis worked well. Captain Phillips, another area raw, another movie, and they had a lot of aerial scenes. They rented 3 battleships from the U.S. Navy. They were spending about $3 million a day, and all the aerial footage was shot with the Alexa and the Gemini 444. And you'll see a whole series of movies. The Wolf of Wall Street is one where the C500, and as I understand it, the Gemini 444 was used for aerial scenes. We don't get to know all the movies that are shot. There are various rental companies that are involved, and a lot of rental companies are requested by the actual production company to keep it quiet. So unless there's some reason to know, we don't get to know. But these are the ones we know of. The Gemini 444 is very popular with the Alexa, very popular with area raw. But not everybody that uses an Alexa uses it in area raw mode. Episodic TV is generally not in area raw. And episodic TV with an Alexa is usually done in ProRes. You know, it's nice, easy, quick. Not the highest quality, but it's quick and it has an established workflow. So there's not a whole lot of episodic TV. We have done many high-end commercials. There's a JCPenney commercial that's going to be done at the Academy Awards. And I don't know about the BMW commercial. The Gemini 444, without any extra cost options, you can record from any standard HD SDI camera. There are a couple of HD SDI cameras out there that don't conform to SMPTE specs. And as such, we can't record from them. We handle all the different modes, single link, dual link, HD SDI 3G, HD SDI 3G dual link. And without extra cost, you can record in 10-bit and 12-bit. Extra cost options include area raw, Canon C500 4K RAW, and 3D. Pricing, $6,000, $3,145 for area raw, and $2,495 for the C500. Avid DNX will be free, and 3D is $1,995. Yes?
On the DNX, what flavor DNXs will you do?
All of them.
All of them, from 30 all the way down to 30?
We're going to do
Just repeat the question for our live stream.
The questions are, which of the Avid DNX HD formats will we do? We will do the 8-bit ones, all the way down to 36 megabits per second,
and then we'll do the 10-bit one at 220, and then there's some others in between. So it is our intention to do all of them.
And is any ability to simultaneously record ARRI RAW and DNX?
We don't know yet. That is a very obvious thing. That is something that we want to do. We are still working on our Avid DNX HD. We just hired 2 additional engineers, very high qualified engineers to help us get this Avid DNX HD out quicker. We don't know yet. If we can do it, we will. We see a tremendous advantage to be able to record ARRI RAW onto one SSD and Avid DNX HD 36 on the other. It is one of our goals. I don't want to promise it until we know we can do it. Okay, hopefully next week. We expect to come out next Friday with a new firmware. This is a new ball game for us. We've been working on this particular release since last November, and we've been testing it for last month or so. What we're doing is adding another level of protection for people on set. What we're adding is that if you have a power failure while you're recording, you won't lose, but except possibly the last frame that was in process while we were recording. So every frame that has been written out to the SSD will be recoverable. And what will happen is that when you lose power, the Gemini 444 will be off. When you restore power, we're going to go out there and check, and we're going to find out where we were and fix everything, and we'll do that in a few seconds. So we will be protected against power failures. Now, that's due to customer requests. I think we were a little naive. We thought that professional cinematographers would see this little sign on the side of the Anton Bauer battery that you had 1 hour left or 15 minutes left, and so we were naive. So I'm sorry. It hasn't happened very often, or the people don't tell us about it, but they've asked us, especially rental companies. Rental companies have told us, you've got to fix that, and we agree. So we figured out a way to do it, so we did. In our current firmware, when you stop recording, we may have recorded 40,000, 60,000 files. ARRI RAW, Canon Cinema RAW, and DPX is 1 frame per file. That's the way the world is. That may surprise people that is used to .mov or .mxf files, but in this world, it's 1 frame per file. And so you record for so many seconds, you got so many files. You record for 15 minutes, you got a lot of files. And so at the end of a recording, we have to go back and close them all. Because we can't keep up and close these thousands of files that we're creating as we're going along. We do it after we finish the recording. And it was typical, for a typical take, it was taking us 7 seconds. And you're recording in a mode where we're writing to both SSDs simultaneously, it was taking maybe typically 18 seconds or so. And it could get up to 45 seconds or so. So we didn't like that. We wanted to fix it. So with this major change that we're making, we'll close all the files within about 2 seconds. Now, it's not going to take us actually that long. What we're doing is we're going to put a fixed time delay in that when you stop recording, you're going to give us a second or two, and we're going to optimize it to whatever we actually need. And I'm thinking it's going to be about 2 seconds. So you stop recording, 2 seconds later you can start recording Um, Now, I told you that we use an SSD from a very reputable, very large manufacturer of SSDs. And we put our name on it after we do all the testing. Now, there were certain things that you needed to do with SSDs. For example, if you have an SSD in a computer, you know, if you're using it as your main drive in a computer, it's inappropriate for you to remove power from the computer while you're writing to it. It's inappropriate for you to pull that SSD while you're writing to it or reading from it. And the same thing applies to us. However, the manufacturer of the SSD has come out with new firmware for the controller, and this new firmware completely eliminates those possibilities of causing an inconvenient situation with the SSD. So we, for about a month and a half, have been torture testing lots and lots of SSDs with the new firmware in there, and we haven't been able to harm them. Okay, we're really abusing them. So we're changing the voltage that is being fed to the SSD. We're pulling them when you're not supposed to, and plugging them in when you're not supposed to, doing everything wrong, and we've had 0 failures. So this is a big thing. Now, the way this works is you have a Gemini, you have our new release, and then when you put an SSD in there, we're going to give you an option. Do you want to update the firmware in the SSD? And you can say yes or no. If you say yes, we're going to take 3 seconds and we're going to update the firmware in the SSD. And you say no, we're not going to do it. Now, remember, did I ask you, who wants dessert first? Well, I do, but now it's time to answer or have any questions. Oh, we got a bunch.
You were saying you can shoot the area wrong 4:3. If you're doing anamorphic, will it de-squeeze on the output and also onto the monitor as well?
We do a de-squeeze. We do a de-squeeze on, oh, excuse me. The question is, if you're using area raw, if you're using 4x3, do we handle the anamorphic de-squeeze? And the answer is yes. Only for 2.0. We don't do 1.3 right now. And I would like you to consider our de-squeeze to be version 1.0. We do it. We did it one way. I think we can do a better job. And we will do a better job as soon as we get time. But you can see, I mean, you get a nice visual indication on the monitor. Okay, but it's not perfect. Yes?
Anyway, I own a Gemini and I'm pretty happy with it, but I was wondering if there's any future firmware updates that are going to allow the SSD cards to be formatted in a computer. That's my first question. Right now, I think they're only able to be formatted in the unit itself, and I'm just wondering if there's a way to expedite, the format time so the drives, are ready to just kind of plug and record. And I can't remember my second question now.
Well, why don't I answer that?
Oh, I remember. Okay.
Okay, so the first question is, can we write some software that would allow you to format the SSD in a computer as opposed to having to format it in the Gemini? And the answer is yes, we could. We haven't gotten to it yet. We're a little busy. This is what I just talked about was a major impetus for us, so we put other projects on hold. We've had that request, and we would like to do it. Now, not to mitigate this, but so that everybody knows, the SSD, when you put it into the Gemini, it takes 1 minute for a 512 gigabyte SSD. And I would love that to be done as you suggest externally. Okay?
Can I
Yeah.
follow up with, and my second question is, I know when recording at high frame rates, it requires two drives. Is there going to be a future update that allows you to record to just one drive when shooting high speed over 30? I think it's 40 frames, excuse me.
Okay, so you're shooting in 4:3?
No, 16.
Okay. Right now, in 16 by 9, we go up to 30 frames per second, and we only need one SSD.
Right.
But at above 30 frames per second, we need two SSDs, and that's a matter of the speed of the SSD and the speed of the hardware in the Gemini. I do not expect that we will be able to improve that in your Gemini.
Okay.
SSDs are getting faster, but they're not fast enough yet. And then the Gemini was limited by the hardware that was available, the electronic chips. And we're stuck with that.
Okay.
So the answer is no.
More questions?
So what frame rates will it record up to?
Let's take Arid Raw. One Gemini will record up to 60 frames per second in 16 by 9, requires two 512 gigabyte SSDs. And in 4 by 3 mode, it will record up to 48 frames per second.
Which is that's as fast as the camera can go in 4:3 mode anyway.
So every mode that the Alexa can do in Arid Raw, we can record. Every mode that the Alexa can output not in Arid mode, we can record in one Gemini.
What about on the Canon C500?
Okay, on the Canon C500, we have certain limitations. We use two SSDs typically, but not all the time, if you're recording from the Canon C500. And we can go, at this moment, with one Gemini up to 60 frames per second in HD, 1920 by 1080. Next Friday, we'll be able to go up to 120 frames per second in HD, 10-bit, I believe, using two Geminis. On the C500, we've got things worked out that if you need to record real high resolution, yeah. On the C500, you can record 4K at 60 frames per second, which is a lot of data. We're talking about 660 megabytes per second that requires two Geminis. And it's all set up. You just plug one cable from your C500 into one Gemini, and you plug the other one, the other cable that comes out, and you do a second Gemini. You start recording on the camera, they both start, they both work. It's a proven system. It just requires two Geminis. But it's 660 megabytes per second. A lot of data.
So thanks, Dan. Excellent presentation. I just want to say just one thing that kind of got quickly glossed over in the beginning, but the Gemini 444 is a tiny device. I mean, it really, when you first look at it, it looks like it's just an onboard monitor. It's a very thin, very lightweight design, and the front of it just looks like a screen, and it's actually then a touch screen. That's how you go through a very straightforward menu. So as far as the operator is concerned, it's extremely straightforward and easy to deal with, and it is a very capable machine. It records uncompressed HD, it records Arid RAW, it records Canon RAW. You can do lots of great things with it. I want to move over. Oh, Andy has one last thing he wants to mention before we go over. Well, you got a hand mic.
Just a correction from before.
Oh.
So our friends from Canon are here. Joe Bagagas is here, by the way. Just he's over at Canon, big brain, one of the many. And he mentioned to me that I said the file names could be transferred from the 500 through the raw data to a keyprobe quad. They cannot. It doesn't say the file names through. So
So anyway, but whatever information does come through will be recorded. At least there is that. Yeah. So we do have representatives from Canon, and forgive us, you're also interested with such great questions. We are running a little bit behind where we had wanted to be, but we will stick around, and people can continue to ask other questions from our manufacturers. And on that note, let's go over to Sound Devices with their excellent recorders.
I'm just the sidekick.
All right. I'll use a little volume for you to make the signal noise ratio a little better. Good evening, everybody. Thank you for sticking around. I think by now you probably all have your PhD in alphanumerics and acronymology. Have you got it? Are you with me still? Are you still alive? Are you awake? Oh, yeah. Thank you very much. It was great. And to all the other manufacturers, participation this evening was great. This is friendly camaraderie. We're here this evening. I'll introduce myself. I'm Pat McConnell, and my associate in the field, John Tatulis, are here to tag team information for you about Sound Devices and our PIX series of video recorders. And yes, we're Sound Devices, but it's also the play on the words in the name. It's a sound engineering design for video. I've got a couple of bullet points and some things to talk about, but I'll try to expedite this. I've got a number of devices in the outer room that would be much better in your hands rather than 50 feet in front of you and mine, so I'll save that for after the presentation. Come on out, poke some buttons, I'll show you the shortcuts. If there's anything else that you want to go through, please ask plenty of questions. So, first off, a big thank you to Mitch and Andy for the presentation and to AbelCine for putting this whole thing on for us tonight. I'll take Beatles for 500, John. Right? We are all here because there's a need, right? The need is that we want a tool to provide a consistent deliverable, all right? There's a lot of different products offered this evening, but those technologies, as they advance, are the need that the industry has created for all of us to work and us to work hard to serve you with our products. I'll do my best to show you some of the unique benefits of the 240i, which is the specific presentation product we have here, and then introduce you to the rest of the products in the PIX family briefly. All right, so as we go into key features, we've talked a lot about codecs this evening. We'll make it simple. We can do ProRes, their standard, and their high Q. It should be HQ instead of HD, but high quality. But also including now with our 3.0 firmware upgrade in the existing devices we've had in the field and with the new products we're shipping for the 240i, we now have the capability of working in ProRes 4444. So applause here. Free upgrade, Mitch said, yes. So if you already own the existing product, hit the website. It's all there for you. And we will work in DNX HD, and we'll work in every format that you'll want to in that codec also. For I/O on the box, we're dealing with a 12-bit, 444 capable 3G SDI input at this point. We'll accept SD, SDI, HD SDI, and 3G SDI. Can I get an acronym amen? Okay. All right. So in addition to those things, we've included in our device, we've tried to kind of do a greatest hits package. We don't do everything, but what we do very well. And our reputation for audio and video products is fabulous for dependability in the field. One of you guys had said it tonight, whichever device you decide to purchase, think about what the price of failure might be in the field. So whatever you buy quality, right? So inside this, we've included a frame rate converter and scaler. We can do up, down, and cross conversion and pull down removal. If you want to talk more about that in detail, we'll geek out, spin our propellers really fast right outside the door.
I do want to spin my propeller for just a minute because Mitch was talking about the cadence acceptance and the Atomos, which requires motion in the frame to pick up the cadence. We too do that, and we can also pick up cadences that are not necessarily just 3/2 cadence, because there's some of the Panasonic cameras, for instance, will do unusual cadences, and so we can pick those up as well, and we can write those files and provide those unusual pull downs.
All right. Are we supposed to like run over and tag before we do that, or are we just good with handing it off? Okay, I'm good. Also, we'll do aspect ratio conversion for you. We've also included a time code generator on board in the device, not just to sync, but actually to generate time code. It's incredibly accurate and very low drift. That as a master clock for multi-camera and double system sound applications. It's the same time code topology as we've used in our field recorders for audio. We've also included a 5-inch IPS display as an accurate field monitor. We've got button shortcuts, show you all those afterwards, that'll offer focus assist, edge enhancement or peaking, exposure assist, zebras and false color, and then also audio metering for the audio inputs on the device. We will have 2 media sources on the device. You can use SSD or compact flash recording. If you really wanted to use something less than SSD in quality, you can. As far as a movable drive, we can work with it. But at the point that SSDs, the capacities are increasing and the costs are decreasing, that's just what everybody's using, so that's what we accommodate and work very well with. You don't have to purchase a proprietary drive from us. There's a list of approved drives on our website, and we work to update that regularly for you. There's fast transfer via the Pix Caddy. You want to talk a little about the Pix Caddy, and I can pull it out and actually just give a quick little show on that.
The Pix Caddy is a device that attaches directly to the drive. We use 2.5-inch drives, like several other manufacturers. And these drives have edge connectors on them that are designed for use with limited number of insertion cycles. They're designed for about 40 or 50 insertion cycles.
Listen to this.
So that's a latch that requires 2 fingers in order to remove that from the machine itself. So this caddy is a nice tool to quickly and easily grab the medium out of the unit itself. You can hot swap these. As long as you're not recording, you can remove the drives. And it has FireWire 400, 800, USB 2, 3, and eSATA. So it's a very quick and easy way to lay off your files or do your file transfer.
Last but not least, we do have cascade capability with the 2 media, so you can overflow onto the CF card if you want to. Audio capability. We built a device with the name Sound Devices that has incredible audio capability. It's what we're known for, imagine that. Superb audio quality, so it matches that of our field recorders. If you want to spin your propeller, we can talk all the specs in the world. But a couple of the advantages on the device itself is we're actually using full-size, field-accessible XLRs and BNC connectors, acronyms. See, I'm going to advance quickly to the bonus round. I'm going to get a PhD squared. The input list is mic or line level input. We can also accept AES on here, and then it's 2 channels for analog, 4 channels of AES capability, and then over the SDI input, we can handle 8 channels of embedded audio. You can mix and match that, and you can addend it. If you had 2 channels coming in on your embed, you can actually add an additional 2 channels of analog to that. You have meter and gain control on the device. It's very accurate. That covers that one. Playback. We've actually, internally in the unit, and I'll give you a little demo on this outside, we've got playlist generation, file marker placement on the fly. We can create loops within that structure, and then we can actually pause and slow motion playback, fast forward or reverse, and we can do frame by frame access to that. So a lot of stuff in that little 5-inch field monitor that if you need to take a peek on site, you can do it, it's easy. Power capabilities for the device, we've got a 4-pin Hirose that's 10 to 18 volts in. We too will do a D-tap cable if you wish. We will allow you 2 Sony L-mount batteries, and those are in parallel operation, and they'll charge when the unit is powered down. External control, we will behave very well with SDI record start-stop flags from all of those manufacturers, Arri Red, Sony, Panasonic, Canon. Also with the Arri and Red file name metadata is also transferred. Record runtime code advanced from the camera and switch closure and link. if you need to. There's also even the capability if you want to have a tally light that you want to wire up on an LED for yourself that you can mount elsewhere off of the device, you can plug that into the Lank thing. You know, if you want to figure out some fun stuff to do, we've got, well, I don't know if I've actually mentioned it. John actually heads up our tech support department, and we have live humans out of the cages that you can call our facility in Reedsburg, Wisconsin. And they speak English very well, articulate, brilliant individuals who know tons about our products. So you can get a human to get an answer. If you'd prefer just to send us an email at whatever hour you're up working, that's great too. We'll get back to you promptly. Oh, and last but least, not least, we've got USB keyboard input if you want to input metadata or whatever it is that you need to do that. It'll also allow you some start and stop control and a couple basic functions for that. So this was just a little blurb that I took off of our website when I mentioned that we had a 3.0 firmware upgrade. I'm relatively new to the company, but I have a lot of pride in working with these guys. We've got experts from all over the world working together to put together these products. And our head of engineering, when I had started a few months back, had told me about this release we knew it was capable. I had asked him a couple of questions about it, and he said, don't worry about it. I'm like, well, what do you mean? And I think of it as Matt kind of designed the box, obviously forward thinking, but it's like Cracker Jacks, if you remember them. There's a secret toy surprise inside. We don't charge for those firmware upgrades. It's not just a fix, but we regularly, with our products, try to implement features and input from the field that you send us, email, comments, you know, anything that you want to share with us tonight. We take it back. I actually have to write up a report to share with the engineering department, and they listen. A couple of things that we added with this last upgrade, just so you know, is, as I mentioned, we'll do the ProRes 4444. This was the one where we took what was a standard HDI input, and it'll now accommodate 3G SDI. We also did an on-screen display for timecode, and we also have an audio delay on the outputs if you need to be able to align things for camera synchronization. So quickly, to introduce some of the rest of the PIX family, we have a little brother to the 240i, and that is a 220i. Very similar in form factor, a lot of the same features, same display. However, it's HDMI input and output only. It does not have a timecode generator on board, but it has a great price point, and if you need those applications, it's available to you with the same quality. We have increased our warranty. I don't know if you know, but our warranty in the field now is 2 years on all the Sound Devices products, and I hope that you won't have to worry about that at all. So the big brother, little one is 220i. The big brother is the 260i, which we are shooting to ship this month. You'll see a demo here. If you need more information, you can hit the website. This is 2 units in a rack, but it's the same feature set that we've already told you all about in the 240i in a half rack, 2 RU rack space device. And the basic, or well, not basic, but huge difference is compared to a 240. It's not a camera mountable field recorder. It's not designed to be portable as such. But this one will do simultaneous recording of up to 4 drives. And as you can see, we can dump the door down. This is 2 units mounted side by side, and this one has the door tipped down so that you can see that we've got 2 drives on there. There's 2 eSATA ports in the back. Question?
Different codecs on each drive or the same thing?
Currently, with the first release, everything has to happen simultaneously on all 4 drives. Good question, though. The other thing that this is going to offer that we don't do on a 240 is network control. And it's pretty easy to show you some of the stuff on the back. We've also expanded some of the additional capabilities. We've got remote control with GPIO if you want to use a contact closure switch of some sort, or whatever works for you, we can do that. Or it'll do 422 control. And then it'll also do network control via PixNet, and that's the free GUI that we offer for you to be able to control the device via the network or Ethernet jacks that are on it. In addition to that, power on it is a 4-pin XLR. It's 10 to 27 volts. And then we've expanded some of the audio capabilities. So I mentioned before on a 240, we've got 2 channels of analog, microline level, 4 for AES, and then we can go to 8 for embedded audio. And you can mix and match some of that stuff. This will give you 8 channels of analog input and output. There's XLRs, a couple XLRs on the box at line level only. But then we also have the DB25 breakout which is basically like a tascam breakout for it. So if you want to be able to take ins and outs of the box for line level, it's 8 channels. There's 8 channels of AES. So if you need something that's performance space and they want to be able to record in 96, we can do that along with the 3G SDI video. So that, and then in addition to it, we are now running, I forgot to hit my bullets here, otherwise I probably shouldn't talk about it, right? 16 channels of embedded audio over SDI, and if that's not enough, 32 channels total capability, and that also includes Dante audio networking. If you'd like to know more about that, I'll hang out and talk with you afterwards, but knowing that most of the people here are running a camera, and we don't really care if it has 32 channels of audio, however, there's a lot of new opportunity that's offered in the box that I think that our markets will grow into. Specifically, some of the Ethernet connectivity that this box provides will help us not just use 32 channels over Dante. There will be applications for that, and if you don't know about it, Dante is just a single Cat5 cable, simple audio network that's real easy. It's just kind of plug and play, very easy to use. And most console manufacturers will have that capability in one way, shape, or form. But it also works as a web server and control for PIX control, as I mentioned. We can connect multiple devices to a network, and it's an SMB file transfer, meaning that when you hook that stuff up to a network, you'll see those 4 drives occur, and you can drag and drop file transfer from that device on site or remotely. So if you start thinking about that, you're probably not going to be using the device in front of a camera working their remote control from home. But if it's someplace that you work regularly, if it's an installation or a facility that you would like to have this capability and you can access those files at any hour or any transfer time that you need or want, that's something that we're excited to be able to offer. So, any questions?
Can you access the files while they're recording?
No. Good question. Oh, yeah, sorry. Currently, we cannot access files while it's recording. We'll have to wait until the file's completed, at which point you can make the transfer.
I mean, if there's one file already on the drive while it's recording something else, that's what I meant.
Not currently.
Okay.
The 220 and the 240, what happens if you lose power while you're recording?
Good question. Can I take it? Yeah, absolutely. With the 220 and the 240, what happens if you lose power while you're recording? Are you redundantly powered?
Well, let's say you're not. What happens to the files?
Okay, so you may lose that file. That file is going to continue to write, and it will be intact on the volume, but its FAT will not have closed if power is removed. So the file will be there, and you can recover that file with a file recovery utility. Depending exactly what the condition was with the power failure, it may not be a recoverable file. So I think that's where Pat went with in terms of the redundant power. That's one of the benefits of having the L-mount batteries on the back side. You can always have a battery and always have one single battery, even if you're powering off of a DTAP or powering off of an external Hiroshi. Gives you that extra protection that you'll always have some power on there so that you can close files and have more security.
Right on. It's what I call the belt and suspenders method.
And one more. With the 2 drives in it, the card and the drive, I know you can continue recording. Can you continuously keep recording if you swap out drives, or is it only when you fill up the 2 it's done?
When you fill up the 2, it's done.
Okay.
You'll need.
If I may,
Yes.
the question is, you have 2 drives on a PIX 220 or 240. You have SSD and you have a CF card. The question is, can you ping pong back and forth if you kept switching between them so that you could have a ongoing continuous record? As you filled up your SSD, you go to the CF card. Could you then remove the SSD, stick in a new SSD, so that when the CF card completed, it would just ping pong right over to the new SSD, and you would just have an uninterrupted recording?
You want to verify that for me, John?
Yeah, that specific scenario is not supported. So it will go to the next drive, but it will not continue to go back and forth.
It won't go back again?
Yes.
So we verified that we do not have infinite drive capability. That sounds like a Star Trek thing. We should send that one back to engineering. Right.
Hi.
Hi.
As a reseller of
Let's make sure that people can hear. There we go.
I have customers that get a little nervous when they come across a dead pixel in the display. How would you address that concern? That's the first question.
Any LCD has the potential of dead pixels, and that's something that we look in QC to make certain that we don't have dead pixels. But if there is one, and if it's in an area that is a critical area, we'll certainly swap that out.
The second question is, I've seen both of your products, your product and the Atomos in action, and I have a few customers that feel that the touchscreen is a bit of an edge over your product. How would you address that as well?
You know, some people love touchscreens, and they're a big benefit for some applications. We felt very strongly against a touchscreen because a lot of times, especially when you've got a monitor that's a high-performance monitor, you're not going to be wanting to touch that and to block its view. And with our user interface, with the control wheel on the right side and a very quick way to get into the menu, it's an incredibly fast and easy way to get into that setup menu. So we like our interface, and in fact, we carried that same interface along into back into some of our audio products as well because it was so well received.
And the last question, when is the 260i shipping?
The 260i shipping is, we're hoping for February, so we're on track for February, barring something that may come up, and these are quite imminent. These are in the final stages of software QC.
Thank you.
Any more questions for sound devices? I just want to point out one thing that I really found important with the PIX recorders. It's, you know, as an old analog guy in a digital world, I look at this box and you know, there's real buttons, but if I had a battery on here right now, when you actually hit play, it lights up green. When you hit record, it lights up red. It's incredibly intuitive device that it just, you know, it's like a tape deck. You kind of know how it works. But just getting into the real construction of it,
yeah, I was going to say,
clients,
I'm having a little trouble with glare. Can we put this hood on there?
Yeah, you got a hood on there, and you have it's felt lined, but
actually that's
more
velvet. And I'm going to interrupt only because we're.
What
do you think if we put like a dogs playing pool option? Would you have it installed?
Well, what I'm getting at is in here, clients and all of us do stupid things sometimes. And I look at a product, I look at a history of a company that's done products for real end users out in the field, abusing and just beating the crap out of gear because you just do whatever you got to do to get the shot sometimes.
Not you guys, but everybody else.
And I look at this product, and it's just on by magnets, but I can do that. And I can do that. And then I can do that. And that says to me that I just know in the field when you got to grab, you got to do whatever, your handheld, whatever, you're going to do this. You're going to just move the thing, you're going to grab it, you're going to pick it up, your director is going to look at it as a monitor, and they're going to do something stupid like this. And that's what you get. And that's that just shows a consideration of design and a quality of build that shows that, you know, it's a real manufacturer understands how people use their gear. So that's one of the things that you get when you buy a Sound Devices product that I find quite entertaining.
To briefly spin the mechanical engineering propeller of our engineering staff, the very first design of that hood also had those 4 magnets, but didn't have the little clasps around the edges.
Little edges.
And so shear force, camera operator swings the camera around, or a camera assistant comes by and he knocks the hood, you can knock that off quite quickly. So we made the change to that when we went into production. So you know, those are things that we are conscious of, and that's a heritage of our production background from our audio products, and now moved into our field audio product or video products.
Right. So I want to thank you. I want to thank all of our manufacturers today.
Thank you, everyone.
I want to thank all of you for attending and coming here today. Thank everyone in live stream who hung out there with us. We went a little bit over tonight. We're going to still have time for everyone to go to the manufacturers' tables who are here today and see all this stuff. I want to let you all know that the AbelCine Expos are an ongoing program, and as such, we will have another AbelCine Expo here in New York soon. Our next topic is planned to be on-camera monitors. So another very useful tool that hopefully you're all interested in, and hope to see you there soon. Thanks for coming.